one another versus the content in the generation condition tended to gravitate towards one another. The diverse set of substances sort of expanded the space that the sort of direct input space started with. And then, using this data, we can start to sort of characterize each of our individual users as well as the sort of cohort of all the participants who participated. And in this space, we have, for example, this is just one user sort of looking at their total semantic area across treatments. This is where some of the interesting behaviors start to sort of bubble up from the method. In the direct case, you don't get any sort of difference between what was input and what is seen because what they typed is what they got. But then in the selected space, they always subset from that space of things that they had input or seen. So the selected space was smaller than the input space. In the diverse case, or the instance where we gave them new ideas as they went through this process, the input space is the smallest, the seen space is the largest, and then the selected sort of ends up being a subset of what they had saw. And one sort of keen core point, hopefully you can see it on the graphic, there's a little X that marks the centroid of each. The centroids of the folks in the new idea mode tended to move a lot more further from where they started. And there's going to be some interesting effects, we're going to talk about that later, but we kind of called this pulled focus. The individual's sort of content they put in versus what content they selected at the end transitioned through sort of semantic embedding space. And furthermore, if we look at sort of individuals over time, because again, that was sort of a end result, all of the ideas that they saw and had selected from, we can also look at things in the sense of as they go through a procedure, as they see subsequently more and more new ideas. In the case of sort of direct input, they only saw as much as sort of they themselves typed into the system. So we see a smaller sort of area coverage over time. It slowly grows, but it requires the user to be the one pushing sort of the knobs to get things further along. And in our new idea space, we found this sort of interesting almost step function. As they interact with the system, they jumped up into a larger sort of space and then sort of plateaued, and then as they kept going, they might jump into another space and plateau and jump into another space and plateau. And so there's this interesting effect of as you have a language model interacting with a person, whether or not the person keeps pushing on the system or maybe gets inspired by the concept that came back, there's this expansion of the search space, of the consideration space that's being happening. And then if we think of all of our users in our cohort across sort of time and space, we look at this sort of really interesting behavior of the relationship between input text, seen text, and selected text. Those in our diverse case, whether or not they used a search system or a generation system, always had this inverted V, where they started was rapidly expanded up into a much larger space by the system, creating new ideas, and then sort of subset back down into a smaller area based on what they had selected. But for those in the direct space where what they typed was what they got, it was always sort of flat and then a reduction. And we saw this consistently across all of our users. And that kind of makes sense given the study design and the data, but it was really interesting to sort of see how consistent it was across our cohort. And then furthermore, as we run the stats on that, we see there's a significant difference in sort of the area across these different conditions of what they input, what they saw, and what they selected across these two different modes. So clearly, giving people new ideas is in fact doing something. But is it doing a good thing? That's where we wanted to get into sort of the mixed effects of all these things, and we ran some mediation models to try to understand what was the effect of these different sort of scene areas that we just showed were statistically significantly different, and how that affected sort of the what we called focus of our users, and whether that had a relationship with their subjective experience and then the objective evaluations we also ran. And so what was interesting was sort of similar to our first study's results. Subjectively, folks had a better experience across all of these different sort of conditions or these different metrics we evaluated, being inspiration, enjoyment, innovation, and fit, when they were pushed to new sort of breadths, new spaces that they hadn't had before. In other words, when their focus was pulled further from where they started, they tended to report a better subjective experience. But inversely, when we looked at our objective evaluations of the final artifacts, we saw the opposite sort of effect. The further folks were pulled from where they started in their input space into the sub-selected space based on how much they had seen, we actually saw negative effects where the objective inspiration, liking, innovation, and fit went down. So trying to dig into that, we had this question of, well, what is going on here? And so we tried to sort of look at these quadratic associations between the distance between the input and the selected centroids against sort of the subjective and objective evaluations. We did not find a particularly significant effect with the objective evaluations, but they began to sort of look like the inverse of these, which are the subjective evaluations that we see on screen. And so there's this sort of dipping effect of, as you start, you're feeling good about the experience, but then as you sort of get further, it starts to degrade, and then it starts to recover as you go further and further out. And we kind of saw the inverse with our objective data. And so that presented a lot of questions around this idea of, we, I think, tend to over-exude this intention of more ideas, more diversity, more sort of out-of-the-box thinking is better. But this kind of starts to allude towards maybe it's not quite that straightforward. Maybe it's a little bit more complex. And that there isn't always, new ideas are always better, but rather new ideas are good to a point. And so to sort of summarize all these different things that we found and sort of bring us back to sort of a focal point, we found that this semantic area method can quantify more of the nuance of the creative journey, in addition to not just describing the end artifact, but also sort of each of the steps that a person goes through. Really, what was interesting for us was, because we had this multitude of sort of data of what people provided as input to the system, what the system provided back out, and then what they sort of selected from that space, this gave us a really rich way to not just quantify, but also visualize that. And we sort of had this mixed effect on exposing people to new ideas, and we were able to sort of further sort of quantify that more precisely than the initial study did, because we had this sort of mechanism for looking at how this effect changed over time. And a core consideration in all of this, I think, is this concept of what we started to say about pulling focus. Is there a benefit inherently to pulling someone away from where they start in their sort of beginning stage of ideation? Is there a point when you want to stop causing them to drift into a new space? And how do you sort of deal with that in an effective, I'd say, interventional capacity rather than in all of this? This was a post hoc study. And on that note, limitations, we only used textual data from the design aid study in the process. Inherently, it was a multimodal process. And so I think some interesting future work could try to look at how do you apply similar ideas to the visual content that was produced, to the sort of multimedia that came out from the system. We were only working with the text, but I think there's a lot of interesting methods out there for how do you describe diversity of imagery. We also didn't collect any human evaluations of the artifacts during the process. We only sort of assessed people at the end of that when we gave them the survey after they had completed the task. It's important, I think, to really understand that design is both a science and an art. The people sort of judging their process as they go through it might have given us a little bit more insight into the process that they were going through, as compared to us sort of only measuring their experiences at the very end of that process, and then us sort of quantifying that process over time. And of course, UMAP as an approach, great for dimensionality reduction, great for consistent, always sort of repetitively consistent output. However, as with a particularly small corpus, there's a lot of instability in the initial clustering. So larger sort of clusters allow you to have longer sort of term stable clustering layouts. And so in our case, we had thousands of text inputs. That allowed us to have a pretty stable clustering. For someone trying to do this with a really small subset of, say, less than 100, that might be a little less consistent. And this is sort of something to think about, especially as we try to transition this content towards more interventional systems. And so in conclusion, we presented a new method for quantifying the creative journey, something we call semantic area. We demonstrated sort of post hoc analysis of design aid data using that semantic area with an emphasis on this concept of pulled focus. We highlighted the complex interplay of new idea exposure on ideation and creative tasks. And as we think about, again, future work, I sort of alluded to this a couple times now, we're really thinking about how semantic area might be useful in an interventional, interactive capacity. This idea of being able to update that convex hull in real time and to calculate that area change in real time as you add a new input, a new interaction to a system. Do you want the user to continuously keep getting bigger? Is there a threshold at which you say, okay, we need to stop getting bigger and now sort of focus back in on staying in a static space? Oh, and then of course, continuing to balance and explore that interplay between new ideas and pulling one's focus away from where they are. Can we find a balance? And so with that, I want to thank you all for your time. Happy to answer questions. And of course, thanks to my collaborators who are all on screen. Thank you.
Okay, thank you, Stephen. I guess we have a time for about 8 minutes for questions. Okay, let me just take the mic.
I actually have 2 questions. The first one is, I think there were also some studies to use ideation with image models, if you have also found some effects of design fixation.
Yeah, so the design aid study was sort of explicitly trying to get away from design fixation. This whole idea of new ideas being given what you typed is not what you get, but you get intentionally expansion of that idea or change of that idea. In the space of thinking about design fixation and semantic area, I think there might be value in, say, when you notice that that quantification is not changing, when things are staying rather static and the value is staying particularly small or focused. That would be a potential way for quantifying fixation. We didn't have an alternative metric for quantifying fixation, so we didn't compare it here, but that would be a really interesting thing to look at.
Okay, another question I have, you mentioned that you're using the Google Universal Text Encoder, and I was wondering if you were experimenting with other text encodings, because I guess they're very fundamental for your analysis of the semantic space, and especially because the prompts you showed were really short, but I think the longer they get, it's harder to actually like encode them really meaningful in a semantic embedding.
Yeah, it's a super good question, and something I thought a lot about. Future work might be looking at trying this method and seeing how consistent it is with lots of different embedding models, but in our sort of case, we chose that as it's a normalized embedding model, so regardless of text strength input, you always get the same proximal vector size, and so you don't have to deal with funniness of, you know, this string was really long, this string was really short, how do you compare them? So that's very important, regardless of what embedding model you use, to be aware of that. And then, you know, I think in the longer term, we also used, obviously this is all in English, we used an English embedding model. I'm sure there's different effects of using it in other languages and other contexts, and so I'd be sort of mindful of selecting your embedding model appropriately for vectorization of your content. But in our case, I would think that if you're following the same approximate approach of I'm casting text strings into an embedding vector and then using those embedding vectors as a mechanism for dimensionality reduction and clustering, the method should hold, and it shouldn't change things dramatically. However, something to be evaluated.
Morning. Thank you for the presentation. You already mentioned that you do the reduction and then you do the clustering. Do you think we know that you map, we lose some information. Is that computational expensive to calculate the clusters in an n-dimensional space before reducing the dimensions? Because dimensional reduction is good for visualization, but maybe it's not the good thing to cluster. I don't know if you lose some information on that.
Yeah, that's a great question and a very good point too. There is definitely some degree of information loss because we are reducing from, you know, high dimensional space down to 2. That was intentionally selected for this work because it's sort of a first round of trying something new. We wanted to make sure that we had sort of an intuition for what are we seeing, how do we validate sort of the content. And again, 2-dimensional area, I think we can all sort of understand what that means. There are technically higher dimensional convex hull algorithms that we could have used and sort of skipped the whole embedding process or the whole dimensionality reduction process entirely, just used the raw embeddings. But that then leaves you in sort of a non-intuitive math land of how do I describe this n-dimensional volume in a capacity that is approachable. And so the trade-off was selected with the intention of like, yes, we are losing some data, but it increases the intuition of what are we measuring. It would be interesting future work to see if the n-dimensional hulls hold.
Okay, any other questions? Okay, I do have a question myself. I saw that you evaluated your work in that data set, right? So I was wondering how that approach of, or that metric applies to more like artistic endeavors like music generation or music composition, or you mentioned a little bit about the process of like image production, but how do you see, for example, audio or symbolic music being used or how do you see like music composition processes being evaluated through the lenses of a semantic area?
Yeah, that's a really interesting question. We only looked at, I mean, the task was to produce images, but even then we only worked with text, technically speaking, for this. But if you can, well, I guess it's not if, it's you can now vectorize and tokenize functionally all sorts of different things from audio to video to images and so on and so forth. I don't have a strong intuition of you know, the diversity or the semantic area of a audio sequence being as meaningful as, say, in this case, a bunch of different textual strings. But in talking with folks who produce music, who think about, you know, how do I want this sort of envelope of difference and diversity and semantics to sort of expand and contract over time, because especially in this temporal sort of process of music production, you might want to think of how does that area grow and then collapse and then grow and then collapse, or grow and then sort of focus into a singular area as, say, you're traversing thematic or tonal ranges or otherwise. I'm not sure. We haven't looked at that, but I think it's a really interesting question, and I'd love to see work that sort of tries to expand this to other modalities.
Okay, you have time for one last question.
Sorry, I was just thinking more about the dimensionality reduction thing, and I think there may be more to it possibly than just the convenience of being able to look at what you're seeing and understand it, because if you try to do the convex hull in the high dimensional space, I think the higher the dimensional space, the more likely that all the convex hull areas are going to be about the same. And so you won't get the differences that you're seeing, and it won't be interpretable. You won't be able to see anything, I think. I'm wondering what you think about that high dimensional space clustering problem.
Yeah, I mean, I guess so for us, we specifically use sort of clustering and dimensionality reduction across cosine similarity. So we were looking at sort of how similar are these different vectors to one another, and then sort of move them into a flatter two-dimensional space based on their similarity. And so the idea was, or the intuition was, that text strings that are more thematically similar to one another would be proximal, and those that are more different would drift in other spaces. And so the dimensionality reduction step does add a big factor to sort of bringing those like with like and dislike with dislike. And nixing that out of the process, I think, might bring some mess and noise in that you're sort of alluding to. We didn't look at that higher dimensional sort of whole space just because of the lack of strong intuition of what's happening there. But again, I sort of mentioned earlier, I think it'd be really interesting to look at and see if the holes in high dimensional space work out in the same capacity as these lower dimensional ones.
Yeah, that's what I'm thinking. They won't. I think they'll all be the same size. As the space gets really big, I don't know what your dimensionality is, but if it's hundreds of dimensions, I bet all the holes are about the same size.
Worth looking into.
That's what I would guess.
Okay, well, thank you.
All right, let's take that. Thanks, Stephen, once again. The clicker wasn't working. What? The clicker wasn't working. Okay.
Yeah, so one of the presenters of this session is going to present a paper. Samuel, unfortunately, is sick in his hotel room, so we won't be able to present. And the third presenter is remotely. It's all, I don't know if the room, let me see, no, not here. How can I see the Google Meet room? And oh, and she also shared the video because yesterday we had technical difficulties with the presentation. Oh, got up. I got up. We have your video, just need to find it here.
Hello, can you see my screen?
Are you going to present live, or are you going to, do you want us to play your video?
Yeah, I am sharing my screen.
Okay,
And
so, okay, if you're presenting live, that's good.
Oh, Gaurav, hi. Can you hear me?
Yes, so can you see my presentation? I'm sharing it right now.
Yeah, we are not seeing your screen.
Okay, let me try again. Share screen.
It's still not sharing.
Share this window.
Okay, now we can see your screen, but not your slides yet.
Okay, so can you see my presentation now?
No, we see your screen actually, not the slides.
That is interesting.
Yeah, we are seeing your web browser, actually the Google Meeting view.
Well, I have the necessary permissions.
Yeah, there we go. Now we can see your slides.
Okay, awesome.
Okay, so
Sorry about that.
no problem. I'm just gonna introduce you. So next up, you have Gaurav Sahu and Olga Vechtomova. They're gonna present their paper, Computational Modeling of Artistic Inspiration. So Gaurav, the stage is yours.
Thank you. And my apologies, the title, our original title is too long for the slides, so I shortened it a bit. So our paper is actually called Computational Modeling of Aesthetic Preferences, which is a framework for predicting aesthetic preferences in poetic lines using linguistic and stylistic features. So, alrighty. I love the rate, by the way, 25-25. Okay. The creative process, along with the inspiration that drives the creation of art, whether it's visual, poetic, musical, it remains one of the least understood aspects of human creativity, yet it is crucial for the creation of works that resonate deeply with audiences, right? So Rick Rubin described the three phases of creative process into three different distinct phases. The seed phase, where the artist is entirely open to any and all forms of inspiration. Then comes the experimentation phase, where one tries multiple approaches to allow the nascent ideas or the seeds to grow and take shape. And the final crafting phase, where the artist refines these ideas into a cohesive work. Our research focuses specifically on the seed phase, investigating how AI generated poetic lines can inspire new creative pathways for artists. And at this stage, AI generated lines can serve not as direct inputs to the final artwork, rather, we want them to act as catalysts that guide artists into a creative mindset. So, and assessing AI generated content presents significant challenges due to its subjective and individual nature. And most of the metrics or the frameworks that have been proposed in the past, they're too constructive, like like the CAT test or the Torrance test of creative thinking, etc. So, in this work, we propose a novel framework. Oh, sorry. Before I move on to the framework, so there's been some work done in the seed phase, studying the aesthetic preferences of humans. So there's this effect called the wound effect, which essentially plots the complexity versus the pleasantness um, that people find in art. So as you can see, if something is too complex, people tend to like not be too pleased with it, and on the contrary, if it's too simple, not at all complex, that again is not a good signal for pleasantness. So the ideal region is somewhere in the middle. So this is where the sweet spot might be. And there are some other techniques like cut-up techniques, which were practiced by artists like William Burroughs, Kurt Cobain, and David Bowie, where essentially the idea is to just cut up some sections from the newspaper, and then shuffle them, and then randomly draw one of the cut pieces to see what seed ideas come through. And then there are some other works like Burnt Tongue, which was practiced by artists like Tom Spanbauer, where they deliberately made the language so harsh, like forcing people to actually think, behind the meaning of what the artwork is. So even with um, even though like there exists these effects like wound effect and all these things. I hear okay. Uh, yeah, even though these effects exist, there's a lot of studies that actually show us that ultimately human preferences or aesthetic preferences are highly individual. So in this work, we propose a novel framework that addresses these limitations by identifying and formalizing key linguistic and poetic properties of AI-generated lines that best explain artists' subjective preferences during the seed phase. And we move on to developing a system that can adapt to artistic preferences of a wide spectrum of creative individuals. So here's the overall framework. I'm going to be explaining the individual bits in detail as well later on. But yeah, here's the overall framework. So we have a data set of poetic lines that are generated by an AI model, and then we feed it to the feature computation module, where we compute a bunch of different features um, given these poetic lines. So for instance, we compute how abstract these sentences are, what's the level of poetic imagery exhibited by these lines, what's the general valence of these lines, energy, etc., etc. And once we compute these generic set of features for these lines, we then pass it through some calibration networks where we use a small calibration network along with some user preferences to actually align these features to individual users. So, I mean, this work was done like last year, early 2024, and like following this work, that uh, we all know how these latest language models employ techniques like RLHF, RLAIF, and all these user preferences to make responses personalized. So this framework is also very similar. So for instance, given these set of features, it's very difficult to tell like if one person is gonna prefer a line or not. So we use a very small set of user preferences to calibrate these features to ultimately predict whether given a new test line, a human would like it or not. So these are the set of proposed features we present in this work. So let's start with poetic imagery. So poetic imagery is a stylistic device using references to physical objects that appeal to readers' senses, evoking emotions and making abstract, tangible ideas. So to measure this feature, what we did was we prompted a Llama 3 70 billion model, um, 70 billion model to given a line, output a rating between 1 to 5. So and instead of taking the actual number outputted by the language model, we use the weighted scoring mechanism to compute the final soft value of that of poetic imagery for a given sentence. And along with this score, we also ask the model to output its reasoning, like why does it think this particular line has this level of poetic imagery. So let's say for given this sentence, so there's a red to the sea. Um, we don't compute just one feature, we also compute it. So we compute this feature for this entire sentence represented by this last entry in this vector, but we also compute it for the subsequences of it. So we also compute it for there's a red to the, then there's a red to, there's a red, there's a there, and there's. So it's all represented by this. And the reason we do this is because we believe that when we pass it down to the downstream like that calibration network, it's also going to learn to pick up on the temporal dynamics that come into play in here. So moving on to the next feature, we have word energy. which is a composite feature encompassing symbolism and diction, both of which contribute to the emotional and conceptual impact of a poem. We use Llama 3.1 70 billion in a similar fashion to poetic imagery. And moving on, we compute the level of abstraction in a sentence. So ambiguity in a line, which helps us identify lines that are more likely to be unresolved or allows for multiple interpretations. It's also a key signal uh, to predicting whether or not someone is going to prefer, a given line or not. And we use this particular formulation to compute the level of abstraction. So what do these acronyms mean? So DAV here means descriptive action verbs. IAV refer to the interpretive action verbs. SV refers to state verbs, and ADJ refers to uh, adjective. And this whole formulation is given by something called a linguistic category model, where you essentially count the number of instances of these features, and then you compute this value. And there are multiple ways you can compute this value. So we actually used a Llama 3 again to obtain the counts of these, four features. And then we computed this final value for a given sentence. Then we have valence, which is emotions expressed in a lyric line or a poetic line, which is computed using, again, Llama 3.1 as a classifier. So we have an exhaustive list of 31 emotions that we ask this language model to classify a given sentence into. And again, it goes without saying that we don't compute just one value for a given sentence, rather we compute it for all the subsequences of it to be able to capture the temporal dynamics down the line. Then we compute the surprisal, which indicates the predictability of a word in a given sentence, and it's given as negative of log of the probability of the word occurring given the previous words. And contextual entropy is nothing but the expected value of surprisal. So expectation is given as summation over that probability times the log prob. Then we have NPMI, which stands for Normalized Pointwise Mutual Information, and it measures word associations by comparing co-occurrence probabilities within individual occurrence probabilities in a corpus. So formally, it's given as this. Uh, so here, X and Y are essentially the n-grams that we want to compare. So probability of X is given by the count of X divided by N for the total word count, and similar for P of Y. And this whole value NPMI it has a fixed range that goes from -1 to +1. And finally, we have the banality, which is the use of common or cliched phrases, themes, or expressions that lack originality or depth. So we again computed this feature using Llama 3.1 70 billion model, similar to how we computed poetic imagery, word energy, level of abstraction, etc. And we provide all the prompts in our paper that we use to compute these things. So you can refer to the paper and the supplemental material to be more specific. And maybe if we have some time, I'll actually show them. So where did we test these features on? What did we test these features on? We constructed a data set called evocative lines, which is a collection of 3,025 poetic lines generated by our AI system called Lyric Jam. We also have a smaller version with about 200 lines. So essentially in our data set, we have okay, so let me talk about the user study that we did. So in the study, we had in total 10 participants for whom we tried to predict the aesthetic preferences. So two of them actually went through the entire data set of 3,000 lines and gave us like the preferences of whether they, like a line or not. Whereas the 8 other participants, they annotated the rather than annotation, they like gave us their preferences for these set of 200 lines. So in total, we have 10 user preferences for the same data set. That makes sense. And then in this confusion matrix on the right, we are trying to plot, oops. So in this confusion matrix on the right, we are trying to plot the inter-participant agreement. And as you can see, there's not a lot of agreement, like there's a lot of dark boxes, which is a good thing. It also confirms some of the theories in the past, which say that, human aesthetic preferences among humans is highly individual. So some stats about this confusion matrix. On average, I think we observed an agreement of about 63% if you average all these numbers around here. So that means that out of 200 lines, they would disagree on about 60 or 70 of those. So which is, quite big. And one key stat that I forgot to mention was when we constructed this data set of 200 lines, we sampled like 100 inspiring and 100 not so inspiring lines based on the preferences provided to us by the two participants here. So what we observe here is, like low inter-participant agreement, which is a good thing, which is what we want to show. It just goes on to explain that the benchmarking dataset that we are using in this task, it's quite diverse and it captures the highly individualistic nature of aesthetic preferences among humans or creative individuals. So, okay, so now that we've talked about the features and the dataset, I think showing this again would serve as a good, I think it's going to be easier to parse what's going on now here. So yeah, we have a dataset, we compute these features using the methodology I just described. And once we have these features, we then adopted two individual preferences based on the preferences we have. So you can imagine that you only need to do this feature computation step once, and then you just use it, use the small set of label preferences from actual humans to make a really robust classification model. So specifically in our case, we used an 80-20 split of training versus test, where we segregate, like where we kept apart like 20% of the lines as test for testing, and then used the remainder of the 80% of the preferences to train these calibration networks. So this, and we compare it against a bunch of baselines. So let me go through these two tables slowly because there's a lot of numbers here. So let me explain what's going on. So once we computed these features, we tested different types of calibration networks, first of all. So first, we have the deep learning based models here. So what if these calibration networks here are one of these deep learning models? So we tried with the LSTM plus attention method, where we essentially concatenated all the features that we computed in the past, like all the 7 or 8 features that we computed in the past. And then we use LSTM plus attention, where we instead of using the features that we computed, we use the SBERT embeddings. So SBERT is a sentence BERT, which given a sentence outputs an embedding of it. So we used that as the feature instead of the ones we computed. And finally, we used a BERT model to predict the final performance. And again, we used so this table is for the bigger evocative lines data set, for which we have like 3,000 preferences. And this is the performance for the two participants we had. So this is A1 and this is A2. And okay, so here in this first block, we have the deep learning models. In the second block, we have the simpler machine learning models, where we just fed the features that we computed to these models. So we just set these to so in one experiment, this would be a random forest. In another experiment, this would be like an XGBoost model, and so on. And then we pass these features to these models, and then we train this classifier and then tested it on the test set. And these are the accuracies and AUC numbers that we got. And finally, we also tried the few shot method of classifying whether, we can classify whether we can predict the aesthetic preferences. So 200 shot means that we showed 200 examples of inspiring and non-inspiring lines uh, and then before testing it on new test line. 300 shot means we included 300 examples of both positive and negative examples, and 450 again implies the same thing. So what we notice here is something very interesting. So first of all, we see that no matter how many how much data you show to a language model, to a generative language model, it's really difficult for it to actually latch on to what are the key stylistic devices that it should be looking at, because the signals are very nuanced in both cases, right? So like just a slight tweak in some words can result in a line being some inspiring to or evocative to being like non-evocative to the same person. So it cannot rely on surface level syntactic semantic features. It has to actually like understand what are the what's the dynamics of the different key. Like first, it has to understand what are the key like stylistic devices it needs to look into, and then how the interplay is going on, how the temporal dynamics are playing out, etc. So. And we actually performed this experiment for more than 450 examples as well, but we did not really see any improvements. Like on the contrary, the performance started to decrease here. Um, and mind you, like a performance of 75 or like close to 75 or 70% is not really good for a language model who are boasted to have really good generalizable capabilities. And this just goes on to show that subjective tasks are not really these LLM's fortes. However, instead of asking these LLMs to do the final downstream task in an end-to-end fashion, uh, these results show that if we feed it to a machine learning model, so use these LLMs as feature computers as opposed to like the final predictors. I think that's the way to go for these subjective tasks, because we see like really good accuracy numbers here for some of these machine learning models. They're even better than the deep learning based models. And we feel that some of this might be due to some over parameterization that's happening in these deep learning models. We tried to mitigate it as much as we could, but these models just like these simpler machine learning models, they just worked right out of the bat. So we did not really need to do any or much like there was practically no hyperparameter tuning needed in for these ML models, and yeah, there was some needed for these guys. Okay, so this was the performance of different models on the full evocative lines dataset, where we have labels or preferences from two users for the entire 3000 lines in the dataset. And okay, and then this is the performance of different models on the evocative small data set, where we essentially have 10 sets of preferences for those 200 lines in the smaller set. And we essentially took the best performing model out of these two to showcase here. So majority baseline is, yeah, like if you just predict what's the like most occurring label in the data set, and that's what you get. So AUC is expectedly 50% here. But this accuracy number for the majority baseline goes on to essentially show out of those 100 lines, like what was the distribution of positive versus negative examples. So actually some actually had more positive examples, some actually had more negative examples, and so on. But the story but the story here is quite interesting. So as opposed to this case where we have where we have a lot of labeled examples, the um, simpler machine learning models trumped these trumped these like supposedly better deep learning models. Uh, But for the smaller evocated smaller data set, we did not have we saw see the opposite, where where the deep learning models, they outperform the uh, machine learning models in this case. And yeah, these are the performances that we see for all the 10 sets of references in our experiments. And okay, so moving on from the quantitative evaluation, we did some interaction testing to understand what are the different types of features that might be preferred, or what are the among all these like out of all these variables, what are the variables that play key role in predicting the aesthetic preferences for different individuals. So we have not found it for all 10, but we picked like A1 and A2 first of all, because they provided their preferences for the whole data set of 3000 lines. And then we picked this triplet of A3, A6, A7 because they are one of the most disagreeing triplets in the data set that we have. So we can see clearly here that for different individuals, the different variables play like a significant role. So these numbers that are highlighted in gray boxes, they indicate that these features, they played a significant role in the final prediction of a given sentence. So for instance, if I translate this into simple language, it would mean that participant 1. For participant 1, features like entropy and NPMI and imagery and valence, it played a very significant role in determining, the final outcome. For A2, it was different. For them, it was like imagery, energy, uh, abstraction, and NPMI. For A3, it was again different, and yeah, it was also different for A6 and A7. So it tells the whole story as well, that different individuals look at different signals, or they pick on different signals given the same poetic line, and this framework is effectively able to capture all the different uh, variables that they might pick up during for predicting the final aesthetic reference value. And here are some reference profiles in from the data set. So the blue web here essentially, so what we did here is essentially we took the positive lines or the evocative lines and the not evocative lines, and then we plotted the mean value of these two sets along these different dimensions we have in our framework, and then we plotted these. So we can clearly see that even these webs or these preference profiles, they look different for different individuals. So for instance, in here, we can clearly see that this participant um, in general prefers lines with higher surprisal, higher entropy, um, as opposed to like some of the other uh, users in the dataset. And let me see if I can. Okay, so here is the supplementary website that we provide in our supply in our paper. So here we show some qualitative results, and as you can see, for this sentence, the language model outputted this rating of 2.28, and the reasoning it gave was here. And again, so this is for poetic imagery, this is for word energy, this is for banality. So this is in general how, this is in general the format in which we got the output for our experiments, and then we used these numbers to essentially, as feature values essentially. Um, and we also have some other interesting results where, we have, where we analyze the lines generated by ChatGPT, and in general, we observed that it exhibited really high banality values combined with word energy and imagery, say, denoting that it focuses on, really superficial. It focuses on really superficial notions of creativity. It would just, it would be just try to be superfluous, as you can see in some of these lines that it has generated. I mean, some might prefer it, but yeah, I don't know. But at least in the data set that we have, we did not see much of this pattern. So going back to the presentation. So, okay, so these are the concluding remarks. We proposed a flexible framework to compute the subjective artistic preferences of different individuals. This framework, as opposed to its previous counterparts, is quite interpretable, needs less data for user modeling, like less than 200 essentially, and it can capture diverse user preference profiles quite seamlessly. Um, and with that, I would like to thank all of you to listen. And if you have any questions, I'll take them now.
Okay, let's thanks our speaker once again. Since we don't have the third presentation, right? I think we have time for a few questions. Does anybody have a question? Okay, so I have a question myself, Gaurav. I'm not sure if I missed it, but how did you compute so what was the ground truth of your classification problem?
Sorry, how do we compute what?
So you showed that accuracy table, right? I don't have your slides like on my screen anymore, but you showed that table with the accuracy of different methods, like different machine learning methods for classifying Can you show the slides again? So
you
if you go to that slide
these?
with those two tables.
Slide with two tables. Okay.
Yeah, here, right? So can you go back one slide, please? Yeah, here you are classifying the sentences as evocative or not, right? So it's a binary problem.
Yeah.
So what is the ground truth here? So how do you compute accuracy?
How did we prepare this data set?
Yeah, so you annotated like each line as evocative or not?
Yes, yeah. Okay. So maybe I can show you the directive that we passed into the participants. So this is the participation guideline that we presented to all the participants. So essentially we told them that, they'll be shown 200 lines in total, and their job will be to either classify it as evocative or inspiring or not. And we specified that by inspiration, we refer to how these lines would emotionally impact individuals and simulate new creative ideas rather than, focusing on the other things like grammaticality and things like that. And yep, that's how and then we had this done by 10 participants. So we have like 10 different sets of labels for the same set of lines. So that's why there's like different calibration networks needed for different users.
Okay, and all right. No, so I guess that clears my question. Okay, so I think it's time to wrap up. Thank you, Gaurav, once again. Okay, let's just give one next round of applause. All right, so everyone, this is the end of our first session of today. So right now we have a coffee break, and then at 10:30 we are back for our keynote. Thank you.
Awesome, thanks. It was a pleasure.
So just a quick announcement, everyone. Today is the last day of, there is like a a stand over there of books. So if you want to get some books, that's your last chance. And so there is a presentation today, right, at 6 p.m., I think, on our way to the restaurant. And today is the last day for manifesting. So if you want to visit Sirius, right, the particle accelerator on Friday, today is also the last day to sign up for that. Okay? Thank you.
In the seed phase of the works based on the linguistic, stylistic, and poetic characteristics. Be limited to these. There can be Hi everyone, my name is Olga Vechtomova and I'm going to present a paper, Computational Modeling of Artistic Inspiration, that I co-authored with my PhD student Gaurav Sahu at the University of Waterloo. I'll start by showing you a number of poetic lines that were generated by AI. Imagine you're working on an art project and you're interested in finding... Hi everyone, my name is Olga Vechtomova and I'm going to present a
Some lines are energy lines that crisscross the Australian continent. They some lines are energy lines.
I'm very glad to be here introducing Dr. Jônatas Manzolli, retired professor of Arts Institute of Unicamp, and today a collaborator professor of Department of Informatics, Engineering and Research at ICCC in Coimbra. I knew him when I was an organizer at CBGRAP, a symposium of computer graphics, and he submitted a proposal when he would bring a pyramid to the art show. I asked him what, a pyramid? Yes, he did. He brought a pyramid, pyramids for art show. But this is another story. Thank you very much, Jônatas, for helping us to bring the ICCC'25 to Campinas. I'm born here, and I'm very glad to modify this region of our country and our continent, I think, because Brazil is very big. Thank you very much.
First of all, I have to apologize everybody about this delay. And I did what I always say to my students, don't do, I did. So I said, make your presentation small, not so big that's easy to transfer. Don't use too much video material. So I did all the things. And I'm sorry, but we are now in track. So I am really glad to be here because it's a mix of happiness and also saudade. Being here at the Unicamp, where I work for almost 30 years, it's a big opportunity to see friends, to see my colleagues, but also to see the place where I was walking every day. That's very special for me. So yesterday, my talk is much about it. It's about to walk. It's about to perceive environment. And I'm going to try to tell you that this kind of way of being is very creative. What I mean by that is, even if you use machines, even if you go to the environment or machine belongs to environment, being there and participate about it is part of the creative process. I have a problem here again. I have this guy here asking me to access the Unicamp. Let me do a back cancel. Okay, I'm moving. So as you saw, I'm gonna try to see that the environment is part of a creative, or is a part of the creativity process. Yesterday, after having been in the churrasco, I was quite not sleeping, and I remember one thing of my life. And this thing of my life is connected to this book. I don't know if many of you know this book, The Song Lines. And this starts in my heart when I was doing my PhD, and I saw this book in the table of my supervisor, and I saw this real cover, and I said, Jim, what is that? I said, it's a recent book. It's about Aborigines, the way the Aborigines walk in the desert without having maps. I said, wow, what they do? He said, oh, they are singing. By singing, they know where they are. And I found this very special, amazing. And I think reading this book changed my life. I must tell you that, because I start to believe that part of the creative process belongs also to nature, to the environment. And being there as part of it belongs to the whole process. So, and after that, I start to ask myself, I'm not asking anymore who is creative. Or I start to ask this question, where is creativity? Instead of looking for somebody that is creative or looking for a machine that's creative, I start to looking the space or the location where creativity is located. And I think that's very important. It was very important to me. So I want to introduce you what is this, what the idea of song lines. I have here one person explaining that.
Song lines are energy lines that crisscross the Australian continent. They mark the journeys of the creative ancestors during the Dreamtime that did various deeds across the continent. Old people repaint and retell the stories of song lines, and as they do this, they're singing the songs to recall the stories and to pass that knowledge down. So it's like walking in the footsteps of the ancestors.
I hope to inspire you as I was inspired when I was reading this book today. So, and what I'm going to try is to somehow to move around the song lines of things I have done. So, and I'm going to try to at least present some of these things and more or less try to explain what was the interaction, what was the kind of devices. More than that, start to understand how machine and man and also the environment was interacting in that different occasions. So the story starts here. In 1998, with Robozer, this is small robot that maybe was my first song line. It moves to Ada, a big space, and after I moved to to Descobertas, I have Repercurso, Remind, but on all these things, I'm going to try to tell you how I understand how environment, how interactions between devices and process become part of the creative process. So that's my concept today. So now I'm going to move in these song lines. And let's talk about Kepera song lines. I don't know if some of you is familiar with Kepera. Kepera is this robot, a very small robot of 5 centimeters. And it was the first machine that I worked in that process of composing music using collaboration with machines. So in that sense, what was there is that I was trying to sonify the robot trajectory when the robot starts to looking for sources of light and avoid collision. And our first approach, as many people may do, was, how about to sonify the trajectory? Okay, that means like if the robot goes to the left, you have one note, goes to right, another note, and so on. Or if the robot moves fast, you take the coordinates of the space and make it produce music. We start to try it, but it doesn't sound interesting. Suddenly, my colleague, Paul Verschoor, said to me, how about instead of map the coordinates of the movement, we start to map the experience of the robots as trying to avoid collision. In another hand, how about to map the memories of the robots as music? So how about to map the way the robots avoid collision? How about to map the way the colors are changed in the environment? And how about to map the robot sound lines as music? So that was our experience. So, and as you can see here, this is that the kind of, let's say, musical score that Kepera produced. As you can see at the first moment, you have different appetites, food, memory recalls. As much as the robot is moving in space, as much the robot has experience, as much he is taking, it takes a memory recalling. As much the memory recalling or recovered, he is taking the experience of the avoidance of collision, go to food, etc., as a kind of a way of demarcate the experience. And so in that sense, the music starts to be a little bit chaotic, and suddenly we have memories recall. That means the recurrence of patterns that was somehow recovered in space. In that sense, we, from a perspective of having a quite chaotic melody, we are moving to patterns of rhythm and patterns of repetitions. So, and after that, we decide also to work with different orchestrations. So in that sense, not only using the notes, but qualify the experience of the robot with different sounds. For example, using sounds of brass instruments for example, collision. Oh, how about to use sounds of somehow some strings when the robot find, for example, food. So this is all subjective, of course it is. But as we try to do these experiments, we create for RobOzer, we create style files of styles. On the other hand, the file of styles or the kind of scores that are going, as the robot exploring the space, are going to reflect the musical experience of robot as sounds or a kind of orchestration. So that was the first experience. So let's see how it looks like.
Como se ele estivesse dançando. Ele modifica assim, ó.
Die beiden Forscher haben ihrem RobOzer in kürzester Zeit zusammen beigebracht, auf Bewegungen von Orbitbesuchern musikalisch Antwort zu geben.
After we move to this installation, I go to tell you later. What's happened there is, when we start with RobOzer, we have these small robots in an installation that's about 30, well, more than that, 70 centimeters, square centimeters, and the robot was moving around. And after that, we start to have an idea of transfer the experience of this small machine to a large space. And we decided to create this project, the ADA. That means I was collaborating over there. It was the project with many research at the Institute of Neuroinformatics in Zurich. But we decided to build a large space that instead of the robot was looking for food or avoid collision, the space was looking for communicate with people. And by communicating with people, the experience of communication will be guide for lights, for sounds, and for music. And I took the approach of using the idea of cinema, where, you know, in cinema you have three main sound lines. You have the music, you have the noise that goes to the scene, and also you have the dialogue, okay? And for Ada, I compose the music, as you're gonna listen to that. I compose the noise, and I use for the language of Ada, instead of use words, I use interjections, things like that. Ha, So instead of having any language, I use the Ada to try to communicate with people with these sounds of, for example, alerts, or you're somehow find something. So by having these three sets of sonifications, We also combine the sonification with the behavior of people in the floor, and the lights also goes together, the music, or let's say this whole kind of music. So in that sense, when you have strong colors like red colors, maybe Ada was somehow angry. When you have soft colors like blue, maybe Ada was kind or trying to be kind of what's happened over there. So building that, we have this experience of having now another song line. That's the song line of Ada. So, and these interactions with people, we call that time as live soundscape composition based on synthetic emotion. What do I mean by synthetic emotions is that relationship with color, sounds that were guided by the experience of people inside the environment, or inside of Ada. So there's a lot of things happen there, but I will only to give you an idea of one kind of guide of interaction. The music was built up in 4 lines. In these lines, we call that, wow. You can see there, okay. We had some materials that means joy, some materials that means sadness, anger, and surprise. And that's the right side is the side was the music expression, okay? And you have the left side of the graphics, we have the side of Ada. So how it happens, only to be brief, to explain this very complex thing in a brief diagram. So that means, for example, if Ada recognizes a person, what means by recognize? We have some sensor that looking for people. When the movement of people is somehow participative, we say, oh, this person look like to play. So that means, oh, I'm going to play with this person. So when Ada identifies this kind of behavior, she is happy. By first recognizing, she is surprised. And after that, you see the line here, okay? But also she might try to find somebody and there's no answer. The people was walking like that, doesn't feel nice to play. So she would be sad. So when she is sad, the music change to express that sadness of don't find somebody to play with. And that it goes in many different ways. For example, when Ada found that people want to play, to interact, the music becomes more fast, the music becomes with more melodic lines, with colorful chords and colorful timbres. And you can see, for example, interaction goal is okay done, so the music will be represented by joy. And so, of course, all these things are very abstract, but also we use the literature of musical emotion from music psychology to guide the research. So we try to validate the relationship between the music and the behavior. So, and this is what we called there a circuit of integration between Ada and people, okay? Let's see Ada, how it behaves. A very important part of Ada is the floor. The floor is... We would say the floor is the skin of Ada. like this scene because we can see all the things that happen. For example, here in the top, you can see how the presence of people or the location of people have been demarcated by the system. Here you can see the different positions, how they change the behavior of the floor. By change behavior of the floor, we have a feedback in the music. People or start to play. Even you have a pong on the floor. A group of people on one side and the other people on another side, and then try to play with a floor ball. They said pong. I said no, it's just football. At the end it was pong. But it's like, you know, join together and do something together. I think the experience of AIDA was amazing, and it was there for 6 months, and we had 5,000 people visiting AIDA in an exposition in the lake of Neuchâtel in Switzerland. And what was there exposed, and also for me was an experience of work and collaborate with many research in different areas. It was a very, very interdisciplinary approach, and we had talked a lot about how to do it, how different people can think about build this. The only thing I don't like of this entire project, and always when I talk about that, I have to say that after that it was finished, the financial support for that say, okay, it's done. We want to continue, but we're not going to give you money to continue it. And you have to dismantle it. It was lost completely, this marvelous thing. The only thing that we keep with us is the floor, part of the floor. And because of that frustration, maybe my friend Paul Verschoor, that was the chief of the team, we moved to Barcelona to work there in the Pompeu Fabra. So there in Pompeu Fabra, in that new university, so we start another kind of experience. So instead of using, for example, this huge environment, we start now to try to work with interactive performances. And the first thing we had done together there in Barcelona in 2007 was Repercurso. And in Repercurso, the idea was, instead of having this perspective of an installation, as AIDA was, we had the perspective that I have been with Dani and other people here, the perspective of using performance as a way of understand this relationship with creativity and the environment. In that performance, Repercurso, we had two human performers. One is one female percussionist and one dancer, and they are interacting with the Robozer. Robozer is not anymore a robot, okay? We keep the name, only Robozer becomes the system, okay? The system that use many kind of inputs and represent these inputs in terms of sound and music. And we have been working with this paradigm of Robozer for many years. So what I mean by Robozer here is a system. The robot is not anymore. We started with the robot, but we keep the Robozer as the representation of the tracks or the ideas we had from the beginning. So, and also we have a second entity that's it's not representing sound, but representing body behavior or corporeal behavior that was an avatar. And the idea now is to use the relationship between the two performers, the two human performers, as they do their song lines, performing music, to guide a third entity in the virtual world to play with them. And the whole concept of Repercurso came from the idea that life moves in cycles. And we try to make these different cycles of Repercurso in the timeline of the performance. The first cycle was very ancestral. We have sounds of taiko drums. Was the first sound of percussion. Tudum. This is very primitive sound. I love taiko. I have my friends over there that we have talked about it with Ivan many times. Taiko for me is a kind of percussion that touches my heart. So we start with taiko, is a primitive begin. As the taiko drums is sound, we use that difference of duration between the attacks, okay? Tudum, dum, 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 dum. This different rhythmic structure to build the next step of the repercourse. So from a small dimension of the rhythm, we are going to move to the second level of time. As life is like that, you have a small experience in some parts of your life, and you move that to the second level. In the second level, you have the interaction with that kind of apparent avatar. That's not humanoid one, it's a kind of cloud. And after that, the cloud becomes more humanoid-like avatar. In the third level of the interaction. In the fourth level, both reality, the reality of the performance and the reality of the avatar placed together. In that sense, we start to have a kind of mixed reality performance. So that was the cycle of repercourse. As I say, performance and avatar co-creating song lines. A little bit about the technology, okay? So actually, we have two layers. One layer of sensors. That sensor means that how the machines, the computers are going to perceive the interaction between the two performers. And the second level is the level of effectors. How that interaction between that two performers plus the avatar are going to also affect by the computers. So in that sense, we keep this concept of having the creative process as a feedback process. So the machine is there to take material or to take input or data from the sensorial level, process it, and transfer it to the effector level, and make this as a feedback. So, and how we did it? In a very simple way. The performer, the percussionist, and the dancer, how we talk about the idea of they are walking through stations in the space. So that means there's a choreographed map, like a song lines. In these choreographic maps, we knew in advance that something is going to happen, because you imagine the complexity of looking everywhere. So, and depends on the way these two performers interacting, we are not collecting data, we start to do the effectors side. So, and let's move. So at the end, we had this result. The first performance was in the Museum of Contemporary Art in Barcelona. And here is a little bit of the whole story. Opa. Taiko. This primitive sense of ritualistic thing. Now the percussionist. The globe is the starting avatar. The avatar is coming. I don't like to explain, but I'm here to explain more than you have a look there on the internet. I would like to explain what's going on. Yes, you see, there's a third level of composition that I call the metaphorical side of this whole composition. You saw that when the avatar was as a kind of globe, you have seen that the percussionist is performing with a globe, a kind of ball of that means there's very much relationships between the objects and the sound the percussionist is producing with the shape of the things that are reflecting in the virtual world. So, and also these connections also made, for example, you saw the dancer, she make gestures like she is breathing, okay? So that means we worked to give cues for the system. We work with the percussionists and the dancer with some kind of repertoire of gestures. So, and we did a lot of his research on gesture, etc. So that means in advance, the system have some material that is collected before that it can be compared with the gestures that happen in space to react with. So that means we build up a kind of symbolic relationship between sound, gesture, and movement in a way that in different stations when things happen, this can be perceived. So that means there's a lot of previous work. We work for almost 7 months with the dancer and with the percussionist, and we are recording, make tracking of the movement to have this matrix of movement in memory in such a way that when the movement happens, in some ways it can be recognizable. So that the way that this performance was built up. I show you a little bit at the end. Now is the moment where the avatar plays with the dancer. Sorry, I put a little bit. I think it's very nice, this part. Okay, it's not everything that works. I haven't seen. Sometimes the avatar gets stalked. Okay, but that's the idea, is trying to build this interaction. And the sound you heard now is a evolution, is a synthetic sound that have been evolved from the taiko. I apply filtering, and instead of have the low frequency, now I have this live material, but it came from the first level, because the whole concept of this work is we are moving in cycles. Something that happened previously is going to be there in the next, but in a different way. And I must say that, I have to say that because it's touched me, this work, okay, let's concentrate. I did in homage to my father. I lost him 1 year ago, and my experience with her was incredible. Everybody knows that I'm a very crying person, but I did it because the experience with him, when he was suffering a very difficult disease, told me that life is moving cycles. So, and that's the main reason to compose a repercussion. Let's go. So, Okay, sorry about that. Okay, people that know me, I'm Italian guy. Full of crimes. So the next was a crazy thing. Multimodal brain orchestra. When we start to talk about that, we said, oh my God, this is what my friend idea, and I said, Paul, you're crazy. What do you want to do? The idea was, we have been working for many years with body, okay? Interaction with the body, having robots to use the interaction space. Paul came with the idea of, how about to do a disembodied performance? A performance that avoid the body to be part of the composition. Because he wants to try this new technology at that sense that the BCI, the brain-computer interface, that was starting in that moment. And the idea now was, how can you use brain waves and the way you're thinking about sounds or think about interaction, build up the music. And I knew in advance that this was going to be in Prague, and I've never been there in Prague before, and I know the clock, everybody knows about this clock, is very famous. Right? You have the plaza, you have the clock, and also a very enthusiastic of a composer is called Ligeti. Ligeti is a composer that talks a lot about clocks. He says when he was a child, he dreamed with clocks. So what I did was, being inspired by this idea of clocks and being inspired by Ligeti, we had a pre-composed set of parameters that will be there, available to be, let's say, performed by the brain waves. That part of the story that is the pre-composed patterns, I called X motion. Okay, and the multimodal brain orchestra is the interaction between that clocks, that musical patterns that were there, waiting for something, and the interaction that was started by the performance in the stage. And how the performance is done? Let's see here. We use again, these two kind of, the methodology. You have the sensor and the effector. In that sense, the BCI or the sensors, okay? And the effector or the audiovisual that's generated by the sensor. In that sense, audiovisual is the image and the sound, okay? Let's see now how it works. We had this kind of circuit that I explained a little bit, but okay, there's also articles that you can read it. But basically, we have 4 brain performance. And we were using 2 kind of technology. One technology is the P300. Some of you are familiar. The P300 is that. When you give a cue to somebody, for example, a letter, and when the brain starts to understand the cue, that means suddenly you say, let us A. When you recognize the A, your brain plays an electrical signal like a trigger that say, aha, A is detected. Okay, and you have a specific place in the brain where this peak, okay, this spike happens. So in that sense, you can have a BCI, and you can allocate a sensor here. When the spike happens, you have this result. The second technology is the technology that makes how brains, for example, is connected to the rhythm of your internal eyes, your retina. When you look into something, this thing is bright, or this thing is make cycles, your retina starts to play in a specific cycle. So, and after that, your brain starts to reflect these cycles inside a representation in a specific area of the frontal area. So it is too much explanation, but in this way, what we did is, by knowing that, and by know that we can capture these two kind of signals, we decide to compose a performance. The performance was, we have these clocks that was there waiting for interaction, and we have these 4 guys that they are trained, it's very funny, you're gonna see that, to react to these signals, and I was there as a conductor. And my duty was to give signals to them, to looking for A's, or to looking for the exact light that needs to be start the signal. So, and my gesture as a conductor was something like that. I have, this means A, this means B, this means C, and this means D. So what I was doing is I was improvising, really. And by improvising somehow, because I knew what I was there represented in terms of rhythm, I was somehow improvising with the material that was there and can be listened as a string quartet. But what was interesting, that the system doesn't work properly. That means, what I mean by doesn't work properly? The response of people are not precise. Really not. So I give a cue, and one guy, okay, another one, I have to wait. And we start to have this problem at the rehearsal that I found marvelous. We start to have delay. And I remember, Ivan, about Liget, that the most interesting about the music of Liget is the superimposition of layers. And if these layers are not so synchro, you start, instead of having a rhythmic pattern, you start to have a texture, because you have this superimposition. So at the time of rehearsal, I decided to, instead of being so keen about it, I start to put more layers. In that sense, we had a string quartet played by the guys, but instead of having a kind of very much melodic, we have melodic and rhythmic patterns as texture. And we can see now a little bit of that.
Multimodal Brain Orchestra, the world's first mind power orchestra using brain-computer interfaces, plays X-Motion.
It's very much a zombie performance, isn't it?
The Brain Orchestra members play virtual musical instruments through BCI technology alone. When given a cue by the conductor, the performers brain play the virtual instruments to control parameters of music expression and the soundscape in the overall piece composed by Jônatas Manzolli. Central to the X-Motion concept is the exploration of our self through our memories and emotions, and the transformations that they can induce. These transformations will result from the interplay of the mind as an actor and as an observer of its own actions.
So you have saw the person with a glass, don't you? And you seen a lot of images. So I didn't told you about that. What's happened is, as the same way we did this kind of symbolic relationship in Ada, using image and light to express something, there with the music, we had a fifth performance that we call the the emotion performance. So when the music was played, and we had headphones, and we map the skin conductance and the movement of the eyes as a kind of expression how this whole thing are affecting this performer. And when you knew how these things are related to the music, we had this image that we took from a database of expressions. We have this database that people you know that express by image the different emotions. So that means in the level of the representation of the emotion, we have let's say, these imaginary like videos that are expressing this correlation. Instead, in that sense, the multimodal brain orchestra was not only the music, is the experience mapping music, mapping the sound, of course, and also the image together. This is the multimodal brain orchestra. Okay. So now I have the pleasure of having a friend of mine, Dani Gatti, that work with me in this experiment, in this model. So I'm going to present another, let's say, another phase of my life. So I have shown you something about robots, ADA, and also about this kind of interaction. And now I'm coming to what I call the multimodal opera. So in that moment, the technology is not that kind of technology have been used, but my concerns now is more in that opera, how to represent creativity in a libretto. Let's tell you what I mean by that, okay? Of course, because Descobertas was commissioned to celebrate the 50th anniversary of Unicamp. And I was thinking about what I could do to express this celebration. And I decided that for my experience in past, and also by the experience that I have here, that the most important thing that we should represent what we're doing at university is creativity. Even arts, in maths, whatever, creativity has to be part of our game every day. So, and I decided to take, let's say, a very well-known model that many of you know. You have studied that when you start to have your classes about creativity, I guess you know, that the Graham Wallace model of creativity. Yeah, I'm going to recapitulate it all in, but I guess everyone know. Okay, you have the 4 phase. You have the phase of preparation, incubation, illumination, verification, and I map these 4 phases in the acts of the Descobertas. The opera is going to reflect the process of creativity. But talking to Dani, talking to Cynthia, the conductor, and thinking about, we decided that we are not going to tell a story. We decided that creativity is more than a story, is an experience. Being creative is more than a narrative, is an experience of feel yourself creative. So in that sense, we decided to have the libretto not based on characters, but based very much in the movement of dancers. So that means we have 2 kinds of dancers. We have the dancers that are mobilizers, the guys that are walking around, and we have one dancer that's called poet, and the other dancer that's called poem. Okay, you have the motivation, you have the tool, and they are personified by persons. So we give to them this poetic idea, and by dance, they are going to express this relationship. And one thing that strikes me, because I was developing also some technology that we are going to see, But what strikes me when I was composing Descobertas was that I was there in Barcelona, and I started to see the castellers. I don't know if you know, some of you know what castellers means. Yes, this is amazing. I suppose, Rafael, that castellers can be a representation of knowledge in the universities. If you really believe in science, you go to the top of the pyramid, and you are very pleased that this falling down. And everybody is happy to rebuild it, because it's part of the game. And so when I found it as a representation of knowledge, I talked to Dani, and we said, okay, we have to make these castellers in scene, so with dancers, and make them mobiles, because you have to make walk as knowledge of moving around the areas of the university. So after that, many talks, we have this scenario. We dislocate the orchestra. The orchestra is going to give space for musicians, for dancers, and you're going to have the dancers and the singers are moving together. You see the choir is on the floor. It's not that choir singing like, you know. They are there participating of the flux of creativity. And the whole story now is how you combine these elements to the Graham Wallace theory. So, of course, I could stay forever in this, but I will show you the result, okay? Okay, the image is not so good, but I stopped in the moment where they start to build up the castellers as a choreographic montage in stage. So in that sense, I think I am quite to conclude, and I'm going to skip one of the things I have planned, because I think the time is gone. I would like to answer some questions. I'm moving a little bit here, only to show you this project I developed recently in Dunder's Institute of Neuroscience, and that performance also I use the same structure, the same idea of Descobertas. But in that moment, I use the interaction between the singer and the dancer. And the idea now is to see how these two entities, a singer singing an opera and a dancer trying to talk to her, they move together. I'm going to play a little bit of this, and you're going to see one technology we have been working together. Wow, let me see where I am. This is funny. Let's see if I... This is our rehearsal time. When you do this tracking of movement, this is the way the score was done. There's a score, there's interaction. is the stage. We have this. You see that I love blue, isn't it? Okay, some of the things I have said here is on this chapter and also in this book, Computational Modeling of Mind and Music, if you want to have a look. In this chapter I wrote with Paul Verschoor. That is my friend and colleague that I have been collaborating for almost 30 years. And most of things I have done was with him. And this is a collaboration that's still on. So finally, we come back to our metaphor. So we can go together. Just Aboriginal song lines map the land through stories and songs. These responsive systems trace dynamic roots of meaning and invention. Each interaction becomes a verse, each adaptation a refrain in a shared composition between human and machine. These technological environments support creativity into living maps of collaboration. I like this concept of collaboration. In doing so, they remind us that to create is also to move, to listen, to respond with a field of resonance possibilities. Okay, thank you very much. No sync hands.
Well, thank you, Jônatas. So, does someone have any question? Okay.
I thought it was fascinating work you're doing as well, but I think, have you considered in your neuroscience brain orchestra work and the music modality, have you considered peppering in delta wave activity or theta wave activity rather than concentrate alpha wave activity?
I'm sorry, I didn't get your point, sorry.
Oh, so basically, in your musical work, obviously you looked at the P300 and the SN.
Okay,
so obviously, in the brain, you have different types of brain waves. When you're in flow state, you've got delta wave activity, theta wave activity. Have you considered taking inputs on them as a modifier for the music?
Yeah, can be. When we started, we had this more generative idea. To be honest with you, we didn't have time to really adjust the generative idea to the time you had to the concert. So I'm very honest, you know, and I decided that using that pre-composed patterns, it will be safe and it will be also more effective. But this generative aspect of using brain waves, I think is also interesting because I have tried later on here at NICS using that generative aspect of sound in therapies, for example. I had a student that using interactions with brain signals worked at NICS to derive interaction as a kind of way of moving and also producing sounds.
Yeah, because I think also that modification could be used in ways of changing tone or changing timbre.
Exactly.
As a different interface.
But I hope you do it. Everybody does because it's amazing. That means when you have this material, speech material in our hands, and you have sound synthesis as available, we can do many things. But honestly, we didn't make it because I didn't have time. We didn't have time.
Thank you.
So fantastic presentation, and also to see the evolving experimentation process and the creative process. And I was wondering, as you covered more or less 35 years, 40 years?
Yeah, almost, yeah.
Yeah. So you had different phases in sensors and technology. And what's your experience for something you tried to do in the past and now you can do? How can you approach those sensors, all those technology, and your vision about the future with AI? I have to have this question. Yes.
Yeah, of course you have. But the point is that, guys, I did it because let's make more advertisement. I'm writing a book. So, and I organized this. And one of my questions is that, what should I put at the end? So, and my view now is the following. I think we are taking too much efforts in advertising artificial intelligence. Artificial intelligence is everywhere. Everybody's saying, artificial intelligence. It becomes a branding and a very capitalist way of thinking about it. I think we should go more for, if I have to put something in the area of artificial intelligence for the future, I would ask people to learn philosophy a little bit more and engage more with philosophy ideas that would make us more critical about this process. In terms of technology, I think this technology we have now, it's very expensive. It takes a lot of energy. I think we're going to move to another place. But for my area, that's composition, I always am going to say to my students, instead of using the solution, try to destroy the solution. What I mean by that, how about to standardize some solution? Go with technology until the position where you cannot use it anymore. I give an example. For example, if I ask somebody to chat or whatever, to play to me a major chord, a perfect major chord, for sure it's going to happen. But if I decide to make a detuned major chord in a specific different tune, whatever, I can try to do that, but I would have a lot of efforts. So that means my space of source, my space of options can be very short, but can be very large. I think the way you use technology has to make you to open the space, not to shorten the space. And some tools make us to go to somewhere that is very short. And we are happy sometimes, me too as well. I think as much as we can open the space. In terms of technology, in terms of sensors, this is devices that we're using now. I think when I started, Lonnie, to tell you, I use the piezoelectrical sensors. And that was the first story. And now you have many, many other options. But I think I like very much this idea of digital new instruments, NIME, that we are building new instruments as part of the story and to help people to do different kind of music and so on. Okay, I talk too much. Please, Rafael, please to answer your question.
I think it's a wonderful presentation. Thank you so much. I have enjoyed it very much. I have a question about ADA.
Mm-hmm.
The interaction, the behavior of people. I'm really curious about that. No, the installation was for several days. So different people arrived to interact with ADA. Do you see patterns that repeat? You mentioned during the presentation that sometimes they start like to play, but there were patterns that frequently repeat between different people?
No, that was. And we collect a lot of data. There's 3 publications about it, about the data that we collect, and we were frustrated because we want to continue to collect. But I give you an example. For example, this is what's happened is we found out that as much at the beginning, first thing, our idea was to make this a flow. People go in, go out, and we found it difficult to have convergence in the system. So the second thing we did after the third day, we decided to give the duration of the interaction to 11 minutes. So in that sense, we also looking not only to this average chaotic performance, but we are started to looking from the floor some patterns. And the floor is 25 microcomputers. So that means you can map very much the behavior of people from the floor. So the first input of the system was not the music, was the floor. And for example, we start to see that there are people that walk more in one direction than another. So because AIDA was an exposition, but also was an experiment. There are a lot of students working behind the curtains. Even one student of mine from Nix was there. Marcião is not here, but I remember him with a lot of love. He was there. So we had to, let's say, make it work. So exactly, we found some patterns. So that means after being found some patterns, I was there as well, I start to tuning a little bit some of the musical styles that was previously composed to these patterns that were happening in space. So that means the music was gradually reflecting the behavior of people, because also we start to learn how people behave in space. It's not because they are different people, but they are different in their internal behavior, but in their collective behavior, they are not so much. And one thing that's proved it, we had a difficult, well, they are so Swiss, okay? Most of them. So okay. One of the things we did is we had difficulty to say the cycle was ending. So what am I going to do? This 11 minutes only. Well, it was easy. We put something there that make the thing work. We put exit in the corner. After we put exit in the corner, everybody understood that has to go. So in the same way, that's a very funny thing to say, but there are some patterns that we start to persuade more than others because we learn how people collective behave over there, for sure.
Thank you. Any more question? Okay. I think I'll go on myself it's about AIDA 2, I think. You said that you made the experiment in Zurich, right? And I'd like to know, it's more like of a curiosity maybe, there are patterns like sounds that sounded happy or sad, something like that. Was there a moment that you remember that someone participating in the experiment got in doubt if it was something sad or happy, I mean, loudest to act, or like for example, the sound was supposed to be sad, the people found it more joyful than others?
Oh, of course. Of course.
Or vice versa?
Yes, yeah, that means it's not a linear relationship. We are using this for emotion. It was a lot of a discussion because I know you are familiar with Heckman work. Heckman was the guy that has to define some orthogonal response to impulse, to emotion. In the Heckman model, we had to use models, okay? This is unfortunately. So, and we studied, we found that the Heckman model was the best for representing. But the problem of Heckman model is of this whole representation of emotion is that he said is orthogonal, but emotions are not orthogonal. We know as ourselves. So that if you put a space, we have 4 emotions, and you say, oh, when I'm happy, I'm not sad, it's a lie. Okay, but what we did is we tried to make these modulations being expressed by other things. For example, the color was not that bright because, for example, in music, the centroid of the instrument was not so high. So we tried to make these deviations that in this orthogonal model that something is between, with some parameters that also are somehow fuzzy. That was right. The only really emotion that we didn't change because we need that for controlling is surprise. And we use surprise even if people are not surprised as much, but when things has to be changed in the system, we need something to control the change, so surprise was there. And also you saw that we have, for surprise, we have a yellow color, we have bright sounds. So as time goes by, we put more bright sound, we put more yellow. In some ways, we saturate this. It means surprise, that's means. But the other modalities, anger. Anger is very difficult.
Yeah.
For the, I map anger at the beginning with a guttural sound, like I took a trombone, and it means something like, but it doesn't work, so, and so on. But only more one thing, that's a very important question. When we study emotion music, most of research we have done, some of them talking a lot about melody, about chords,
Yes.
about many of the things. And people, we have done tests or so on. But there's one aspect of emotion that's very much in ourselves, that the sonic aspect, the sound aspect. That means if I play you Clair de Lune in a very wrong instrument, you wouldn't feel Clair de Lune. And the melody is the same, the rhythm is the same. What's changed there is the timbre. And timbre is a very important aspect of music. And as much as I move, and I hope to study it even more, I don't think timbre is a only sonic aspect of music. Timbre is a multimodal aspect of music. And because of it, it makes us difficult to work with this. You are making assumptions that timbre only comes from the acoustic signal, and suddenly it comes from here, but your entire body makes some reaction to that. How you deal with that if you only consider timbre as part of the acoustic environment? It's not. And if you go to talk to people, for example, musicians, some of them say, oh, this sound is a little bit bright. Oh, even people are saying, oh, this sound is a little bit blue. And you say, this guy is crazy. Maybe not. Maybe the representation of this sound in that brain of that person is allocated not only in the area of the aural perception, but is also allocated with other connections. In that sense, I say, emotion connects to timbre. It's very much difficult to work with than work only with pitch material. But in our society, in our tradition as Western music, we start with the theory of affection. In the Baroque, and always we're talking about if the scale is minor, major is sad, or whatever. We are making this map, very simple map. This is very simple. And only in some years ago, we start to consider sound as part of the game. Of course, we still having to learn about. But yes, the answer is there are many times that we have this problem of having fuzzy answers.
Okay, great, thank you. Some more question? If not, then thank you again, Jônatas. It was a great presentation, as always. Now we have lunch time, so see you again. 13 and a half. Yeah. Oh. Yeah. Please send the presentations by mail a bit before. Okay. Thank you.
Que é o Victor, quer falar? Não precisa na volta, melhor estão saindo. Também. Explicar que caso do lago just between here and
differentiated, well, not always, but in this, like this one here is, this side here, the hero is the prince, but at some point the princess that has just been rescued by the prince has to go out and rescue the prince himself, who has been ensnared by someone else. So this makes for more complex stories, but computationally this approach, this had never been tested. This is one thing. In the Appendix 3, he lists the actual analysis that he made, and you can see that many of them are actually multi-move tales. In fact, 57% of the tales he analyzes are multi-move tales. And this was 1928, and now it's 2025. We still have no computational account of how you make multi-move tales. So I set out to do that. I had to rely on some extra machinery that I had developed earlier, because the character functions that he uses, like struggle and victory, they don't occur in isolation. You don't start a fight, and it only works if someone actually wins, right? Or this one here, where you meet someone, and depending on how you react to them, they give you or not the magic ring or whatever it is. They only work as a whole, so you have to combine those. And this one I had to add here now, because if we're going to start mixing up different moves, we need to keep track of who is playing what role in which move, and I call this a sphere of action combo, because Prop describes them as spheres of action for the various characters. The set of character functions in which the villain is involved is the sphere of action of the villain, right? Anyway, so I'm using this, and because I'm now going to start mixing up more than one move, I need to know how to interweave them so that the story makes sense. So you can see this, the character functions on this side make for better stories if they are together. You fight someone and then someone wins. You can't start fighting someone at the beginning of the story and win at the end. It doesn't work that way. And in the other case, it's the ones that work the opposite way. You depart on a journey at the start of the story, you return at the end. If you depart and return immediately, it doesn't work. Okay? So just very basic information that I need to use. And this is an example of the architecture. You get, this builds the simple move. Now you get more moves, you mix them together. You have to build a cast, what type of character is going to do each thing. And then there's a bit there where he never mentions how he knows there's a character function. This is someone assigns you a task, but for villainies, he has all this big long list of types of villainies. For tasks, he doesn't, so I had to add that. And then there's this bit that turns it into text, right? And so this is what he mentions, the three big things that he mentioned. This he never mentions. It's never discussed in the book. That just appears in the appendices. And then that I had to add because it was missing. And this is the process of narrative composition on which you can find more. And so this is an example. You can find it in the paper. You can see that it's two moves mixed together. You can see the roles that each of them plays in the different move and how they switch from one to another. And the various things it complies with. This is the part where I had to, there's a number of things in Prop that this has this connective incident where someone tells the hero that the princess has been kidnapped. And of course you need to, when you actually write it out, you have to, the description of this character function has to include a mention of the kidnapping that came before, whatever it was, right? So you can see how this gets handled in the rendition of the text. And that's it. Thank you very much.
Bueno. Questions?
So, if I understand right, this isn't built yet. You're proposing to build something.
No, it works.
It works.
Yeah.
It works. Okay, so all right, then I guess the question is, what parts of it don't really work yet?
Okay.
Or what parts need to be better or something, because it seems really complicated.
Okay, this is, I very carefully didn't write this as the text for the story. It's a text or description or narrative structure for a story, because this is just template-based construction of a description for each of the character functions. Obviously, this is not very good as a story, but this is the kind of thing you could give an LLM to give you a richer text that would look good, but which would ensure that the final outcome doesn't have the simple structure that LLM stories have these days, because you would be using this to constrain it to build a complex structure with several moves that is still consistent. So that's part of the previous work. The other thing that I'm having here is when you put these two together, right now what I have there is a baseline that just mixes them up, so it mixes the characters at random, sort of. You have the characters in one move and the characters in the other, and you have to say the prince here is going to be the hero of that, and the hero of this is going to be the villain of that, and so on. And that is currently happening at random. I'm working on an evolutionary solution to make that better. And there's a number of other things that the cast builder, again, is now a random baseline. It could be improved. And in that sense, it's there are things that could be made to it, but it does work. It basically works.
Hi. Thank you for the talk, first of all. You said in the beginning that this was not formulated by Prop as a grammar, mainly because it was in the 20s, so he didn't do it explicitly as a grammar, at least. Then you said that in his work there is also this notion of move, and you studied how this could be the interweaving of these moves. I was wondering, is this also something that could be captured in terms of a grammar, or maybe is it what you implicitly did in order to get to this overall picture? Or more generally, how much of this can be actually captured by something like a grammar?
George Lakoff, when he was a graduate student, actually wrote a paper that transcribed Prop's account into a proper transformational grammar. But it only works if by relying very heavily on the transformational side of the grammar. And I've been working on it for some time. I still don't quite get how it all happens. But it's in theory, it's possible. I'm not sure. And again, this is Lakoff back in the 60s, right? It's not computational. There's no computational implementation of it. And I'm not sure how easy it would be to get a computational implementation that works based on that. There might be one. So I know.
So something I've seen discussed a bit is this idea of LLM-generated text not necessarily being based on the same causal reasoning as a human generating text. Like if I were to write a story, I would have each action be informed by the previous action, as in like the previous action causes the next action. So I'm curious whether you've applied a structural causal model approach to this, where the text description of the narrative could be structured like a causal model, where you have counterfactual paths, or yeah, is that something?
I wrote an earlier version of something like this only for the simple, for one move, so to speak, for one move stories that was based on a sort of kind of planning operator paradigm, where each action actually has preconditions and postconditions, and they're all chained up using unification. And it worked reasonably well, but it's, as always, it has the same drawback as all of these solutions, which is you need a lot of knowledge engineering to generate for each of the possible actions, the preconditions, the postconditions, and then what usually happens is to do that, you need to, I mean, like sort of marriage. The preconditions of marriage is, oh yes, these two love each other and then they get married. And then that works, and it will get you a causally related description of a story in which people get married. but we all know that it's not usually true, or not always true. And therefore, if you want to account for the other type of marriage, then you will have to add to your, and it expands, and it's a little complex. Oops.
I was just wondering, from a perspective of collaboration, is there any work you're doing where you're looking at the other direction as well? So going from the narratives to breaking them down into these moves that maybe you could mess around with?
Yes. Yes. I have essentially, because I'm fully aware that people don't write stories this way. You create a draft and then you read it and then you revise it and based on your interpretation and what you really want. So I do have another model for a narrative interpreter, and it does that. It processes a story in the same format, and it will come up with this list. It's actually a connected graph of character functions that make possible interpretations and predictions ahead, because it grows dynamically as you read the story. And it also works on how that changes. Sometimes from what we read of the story, we know there's two possible continuations, and while you're reading, you need to keep them both in mind, and then later stages in the discourse will cancel one or the other, or maybe even introduce new ones that you hadn't considered. And that's all in the model of how things are interpreted. But it's a little more complex. There's papers I've written on that.
So does this system only create linear stories, or does it create flashback, foreshadow, and things for delaying events, for create suspense, all of those?
It's, okay. The thing is, the props character functions are not events. They are building blocks for complex stories. So some of these character functions include flashbacks. The connective incident is basically, and here be a flashback, and here someone's told about something that happened earlier, and there's a few others like that. So there is a number of complex narrative phenomena that are captured by prop functions, but there are many that are not.
Thank you very much, Pablo. Please. And also, I believe Pablo is leaving us soon, and he is the general chair of this conference, so maybe we should. Thank you very much.
And you'll have to find someone else for the closing session and give all the thank yous and all the goodbyes. I'm sorry.
Okay, so now we move on. So our next speaker is Mete. You see, I practice. So the paper is called Evaluating Creative Short Story Generation in Humans and Large Language Models. Thank you.
Hello, everyone. I'm Mete, a PhD student at EPFL, Lausanne in Switzerland. And I would like to present our work on evaluating creative short story generation in humans and LLMs. This was a collaboration between EPFL, EDAP Research Institute, UZI, and in Switzerland, and University of Amsterdam in Netherlands. Okay. So let me start with the sort of a motivation for this work. In creativity evaluation, there's been a lot of work recently evaluating these large language models that perform really well in a lot of tasks, and people have looked at their creativity, and we can sort of categorize them in two rough categories. Here I'm just, this is not an exhaustive list, but I'm sort of trying to give a sense of what we are trying to do. There are some tasks that require sort of short responses. These are more like psychometric tests, that alternative uses test, divergent associations task, or remote associates test. And the research has shown that comparing humans and LLMs on this, and they have found that they're sort of perform nearly as humans. Sometimes a bit better, sometimes a bit worse, but the results are a bit mixed. But there are also some other tasks that require long and complex responses, like short story generation or poetry generation, etc. And on these topics, there are some papers have found that mostly they have compared LLMs to professional writers, and then they have found that still the LLMs don't really produce as sophisticated novels or stories as these professional writers. So as a natural question in this work, we want to explore whether LLMs can produce creative stories as good as average humans. So we want to ask, is an average human, ordinary human who's not a professional writer, can produce more creative stories or not, and then more specifically, what are the differences, key differences between these stories produced by LLMs and humans. So we specifically look at the creative short story generation task that's commonly employed to to evaluate human creativity in psychology. In this task, you are giving 3 words, like for example, stamp, letter, and send, and then the participant is asked to create a story, short story, using these words in creative ways. Here's just an example, might not be very creative. So the setup we had is we have 4 item sets. We call these keywords. So stamp, letter, send, petrol, diesel, pump, organ empire, comply, gloom payment exists. So these 2 of them have low semantic distance between them, and 2 of them have high semantic distance between them. And so we evaluated 60 different humans recruited from Prolific in UK. And we, for a fair comparison, we also considered 60 different models. A lot of works have considered only few models with different temperature sampling, etc. Here we wanted to see how different a population of LLMs perform. So we have models from different families, different companies, and etc. Different model sizes. So the instructions that we give to both participants are the same. So we essentially ask them to create a creative story, avoiding some standard templates, and writing a maximum of 5-sentence story. So we keep the setup simple. Our goal is to evaluate this creative story generation in the wild, what's the default behavior of people and the LLMs when they're prompted to do this. So just before I go on, I want to maybe do a kind of, to give a sense of what these stories look like, a sort of short Turing test. Who wrote this story, for example? I have this story from Petrol Diesel Pump. So during one night at my local gym, I bumped into Van Diesel, who commented on my ability to lift my weight correctly. He decided to show me a better way to get my pump on. While I give the chance, I cooked if he had any siblings named after Petrol. Who thinks that this was written by a human? Okay. Who thinks this was written by AI? Maybe AI is a bit, more. How about this one? In the bustling heart of mechanical city where machines, blah blah blah. Now, do you think that this is written by AI or human? Yeah, exactly. The second one was written by AI, and the first one was written by a human. And you can sort of see the qualitative difference there. And this is what we want to capture in this work. So in the evaluation, we look at a few dimensions. So we look at the complexity of the stories, for the lexical at the syntactic level, diversity of the stories, again, lexical at the semantic level, creativity of the stories, we look at kind of novelty and surprise dimensions. And we also, these are the automated metrics, we also ask humans, sort of non-experts and experts, and LLMs to evaluate these stories as well. We'll look at their judgment differences. So let's start with the lexical complexity. As we already saw, probably what's going on. If you look at the kind of sentence lengths, the number of unique words, the red represents the human and the light color represents the AI stories. So we can see that the AI stories are quite long. I mean, here we have the 5 sentences, but sentences themselves are quite long. If we look at sort of the readability score, we see that the human stories are more readable than the LLM. So in general, what we find is that their LLMs generate longer and less readable stories. And we also see the similar trend in kind of average word lengths. So they lose a lot of rare words, longer words. When we look at the syntactic complexity, so we look at the dependency path length. So when we look at the dependency tree of the, so this is let's say the dependency tree of the sentence, then we find all the dependency path, and then we kind of count their length. So if the dependency path is long, it means it's quite, it loses a lot of clauses and stuff. So what we find is again that the LLMs use syntactically more complex stories. We also find this trend in constituency tree depth scores as well. I don't show it, but you can find it in the paper. So we also analyze kind of part of speech use. What we find is that, for example, the nouns and adjectives, etc. The LLMs use more rare adjectives than humans, but the humans use more first-person pronouns and adverbs. The LLMs tend to use a lot of third-person pronouns. Then we look at the diversity of the stories. At the lexical level, we look at the n-gram diversity. So the n-gram is a sequence of size n. So we look at across different sizes of n. So the n-gram diversity is the number of unique n-grams divided by the total n-grams. So if we look at across, from 1 to 5, what we see is that the top is the human and the bottom is the LLM per item set. We can see a clear gap between them as it goes. The human stories are more diverse, lexically more diverse. So what are these kind of n-grams that these models use? So we also kind of analyze that. We see that, for example, for humans, there are not many n-grams that are actually repeated to 5 grams in this specific case. So at most 2 times. But we see that the AI repeats a lot of these n-grams in the heart of bustling city once upon a time. So kind of tend to follow this template. So then we look at the semantic diversity, how what kind of topics and themes emerge. So we use a kind of a homogenization score, inverse homogenization score. This is based on the semantic distance between the stories. So we look at average pairwise distance, semantic distance of each story to all the other stories. So we can see a significant difference between the stories. The human stories are significantly more diverse in themes. And so it LLMs repeated all of the themes. So you might say what these themes are. So we kind of analyze that as well using another LLM because they're really good at summarizing. So we sort of ask them to summarize all these stories into major themes. So these are the kind of AI themes. It always talks about sort of magical, transformative power or symbolism and etc. in all of these stories. But when we look at the human stories, we see a lot of the things about humans, like human nature, the life responsibilities, existential questioning, and etc. So then we kind of analyze creativity of the stories in several dimensions. First, we'll look at the kind of novelty of the stories. This is, of course, is a bit hard to measure. This is something, the proxy metric that we use. This doesn't capture all the qualities, but this has been used before as well to kind of measure the novelty of a story. Here, essentially, what it means is that we look at the average semantic distance of the words within a story, and then distance from that with that and to the older stories from the population of the stories. So this is the kind of the metric that we use. So it's kind of the uniqueness and metric as well. What we see that the human stories are more original in this metric. Then we look at the surprise element. Again, we employ some semantic distance-based metric. So the assumption is that as the story unfolds, the next sentence, if it's more semantic distance than the previous sentence, it's going to be a bit more surprising. So we look at the average semantic distances of these sentences across the story. And what we can see that again, the humans show more variability, and so the LLM stories are quite less surprising. And we also want to analyze this a bit further. We want to see how this changes as the story unfolds. So is this just humans have a high score all the way, or LLMs have a low score? But what we find is that actually you can see that this dynamic is actually more interesting. For the human stories, as the story unfolds, it gets more interesting, as you would expect, towards the end of the story, while the model stories keep a monotone profile. Yeah, so these were all the sort of automated metric results. We also have the other experts evaluate this, and humans evaluate these stories. So we ask average humans to evaluate this story. We had about 96 people. We also ask LLMs, a couple of LLMs to evaluate these stories. and also two graduate students in psychology trained sort of with the experience with creative writing to evaluate these stories. So the setup is that they evaluate these stories on a Likert scale of 1 to 5 across dimensions of creativity, originality, surprise, and effectiveness. And we also ask them to do the same Turing test that we did to guess the author of the story, whether it's AI or human. So they are not, they don't know this information. So what are the results? So what we find is that here we have for each dimension by judge type, we have the scores. And what we can see that experts rate human stories as more creative than LLMs across all dimensions. However, we see the opposite trend for non-experts and LLMs. So they tend to prefer, let's say, LLM-written stories. When we look at the Turing test results, the experts outperform non-experts and LLMs significantly. So then we kind of analyze what are the driving factors behind these judgments. So we do sort of like a simple regression analysis on these automated metrics that we have, try to predict the judgments of LLMs, experts, and non-experts. Here what we see is that the expert judgments are typically driven by the diversity and surprise of the stories, while expert, non-expert, and LLM judgments rely really on the linguistic complexity. So as the stories are more complex, they tend to rate it more creative, but which is not the case typically. So in summary, what we find is that the main takeaways is that the humans tend to prefer, tell simple stories from their perspective that are nonetheless diverse across participants. They use keywords in original ways and then tend to surprise as the story unfolds. While AI stories generate lexical and syntactically overloaded sentences and narrated from the third-person perspective and typically focus on a few repetitive themes and typically predictable and unoriginal. And we also see that when we look at the differences between the judgments of experts and non-experts, we see that the complexity tend to create this illusion of being more creative to the untrained eye. With that, I conclude my presentation. Thank you. If you have any questions. Yeah, exactly on time.
Thank you very much. Really interesting. I'm really glad you added that extra slide on the dynamics and how the dynamics as the story evolves and how that changes. I think that's fundamental, and not enough attention has been paid to it so far. Great, thank you.
Thank you very much.
So apparently, for an expert, it's quite easy to say which story was, or who was the author of the story, an LLM or an human. I guess it would also be easy for an automatic classifier, right? Well, you'll answer me. And I was thinking if it would make sense to look at some of the differences that you found out. For instance, that LLMs generate longer stories and others that you found out. And if you added to the prompt, say, avoid longer stories or write stories with that as at most specific number of words, and same thing for the other features, what would be the result? Would it be harder to guess who wrote the stories? Would they be closer to the humans, better, more interesting, or just a suggestion?
Yeah. Yeah, thanks for the question. I think that's an important question. First, the classifier one, I think this could be used to build a classifier to tell whether it's AI or human, because we have these features. We actually thought about it after that this could be used for, let's say, AI text detection systems or something like that. To answer your second question, that's an important one. Actually, what we saw is that we didn't do this analysis with different prompts, and our goal was to kind of, because if we have the different prompts, we could do the same thing with the humans because they could produce different things. We wanted to keep it simple, but what we have seen is actually internal experiments. When we do really try to, write something simple or write something, still the model, when it sees something about creative, the word creative, it starts producing similar stuff. So we see the same trends, maybe a bit less, but still the same trends are seen in other experiments as well, but we haven't shown it here. But yeah.
Thank you for the presentation, Stephen Rick, MIT. I think you did a good job of highlighting a lot of the things we've already heard about in the sense of, you know, language models average to the mean, language models prefer language model output, so on and so forth. And I think for the sake of making comparisons on strengths and weaknesses of the two, right, humans versus language models, you did a great job. I'd love to push on the idea of, is there a way to bring them together to do better than either or? And I'd love to get your thoughts on that.
Yeah, I think that's a great point, because a lot of work people have been are doing on the core creativity, for example, trying to create with LLMs, not only. I think what's great about them is for sort of getting ideas of the let's say the story, maybe some parts of the story, sort of to get started. I think to get started is a good point with LLMs. It can give you, you know, a lot of these ideas that might be similar, but then it can give you ideas for other things. I think in that sense, it's good. But in terms of just having the AI write, like, you know, the story end to end, probably that's not ideal. What we can see, I think the better alternative is to get, you know, all the ideas, and so that you can build upon those ideas and then write your own way. For example, in daily life as well, when people write with LLMs, the email or anything else, tend to change it after as well, because it kind of doesn't really sound a bit human-like still. But it's still, it has the structure maybe there that we can use. Yeah, go ahead.
Yes. You've used a range of LLMs which differ enormously in terms of size and also perhaps some other parameters.
Mm-hmm.
So I was wondering whether it's fair to put them all in one bag.
Mm-hmm.
I mean, as we know, those LLMs, like, you know, smaller differ enormously from large ones in terms of their sheer linguistic capabilities, linguistic competence as measured by benchmarks and so on. Those differences can be really huge. So I was wondering whether you have the results also by each model, and whether you've looked at the differences between models.
Yeah, that's a good question. I mean, the LLMs we considered here are, yes, they're different sizes, but they are not that small. Like the smallest ones are, let's say, 3 billion parameters, which are already have mastered the language, and they can produce, you know, quite well stories and everything else. So they should be able to do this task and follow the instructions. By the way, we don't have any, let's say, problems with the models not following the task. So they are all following. We actually had, I had a bit of sort of analysis here, I think I didn't include, with the model size on the novelty and diversity. We actually see the opposite trend. This has been, I've seen in a few other papers. The smaller models tend to perform a bit better than larger models in terms of producing more diverse stories, for example. This has been reported. And this seems to be the case because, let's say, the larger models are more prone to pleasing because they are fine-tuned with this human preferences, and then that means they typically don't want to take any risks in producing anything that might avoid, you know, what the human wants. So we haven't done a thorough analysis on this, but the models that we have chosen should be able to do this task.
Last question, very quickly.
Yeah. Okay.
So first of all, congratulations on the presentation. It was very interesting.
Thank you.
So I was wondering if you have any thoughts on pushing the limits of interaction a bit more, because I think it's very uncommon for people that use AI for anything, LLMs for anything, to just like give it a prompt and then accept the answer and that's it, right? We normally try to prompt again and correct stuff too, but I'm not even talking about people correcting, I'm talking about prompting again. So do you also have, do the results change a lot if you guide your model with a second prompt? Does it get harder and harder to predict if it's if it's AI generated or not? Like, what happens when you have more than one interaction?
Yeah, thanks. We haven't done that with this work, but I know of works where they have tried to prompt the model multiple times for diversity. They have also observed that still diversity does not improve. And in our initial experiments, we actually started with few models, not 60 models. So we were doing, multiple parameter settings and multiple prompts, and we saw the same results. But then we moved to multiple models so that to look at, for a fair comparison between number of models and number of humans. Yeah, so the similar trends also follow what I've seen from my experience, the other papers, and as well in my experiments as well. But yeah, maybe it would be a nice, interesting future work to kind of look at it specifically with multiple prompting strategies like that. Yeah, thank you.
Thank you very much.
Thank you.
So now we have a presentation, I think, in Israel, yeah?
Yes.
Can you hear? Aidan, can you hear us?
Hello. Okay.
Okay. Can you hear us, Aidan?
Yeah.
Okay. So, you have 15 minutes. I don't know if you will listen to my rattle, but I will let you know when you have 2 minutes left, okay? So, the next presentation is building artificial intelligence agents for co-creation and improvised stories. Thank you.
Okay. Hey everyone, good afternoon. I'm Gal Kimbon, and I'm here with my research partner, Dan Vidra, along with our mentors, Professor Ariel Shamir and Dr. Lior Noy. And I'm really happy and excited to be part of this conference. And today we want to take you on a journey from the theater stage to the world of AI. We are going to explore what happens when artificial intelligence becomes your creative partner in improvisation. But before we dive into the research, let me show you something magical that happens on improv stages around the world. So let me read you this short improv scene, and I want you to notice something very specific happening here. Player one, start with, remember when we met flying whales last year? And player two respond, yeah, and one of them invited us to the carnival in Brazil. And player one answers, yeah, and then we danced samba on its back all the way there. As you can see, in just 3 lines, these two players created an entire fantasy world. Flying whales, carnival in Brazil, and dancing samba. None of this was planned. This is the magic of improvisation theater. So, why this yes and rule works so powerfully? It has 2 parts. The yes, so instead of rejecting your partner's idea, you accept the reality completely. And this creates a psychological safety. Your partner feels heard and supported, which encourages them to take creative risks. And we have the end part. You don't just accept. You build upon their idea and move the story forward, and this is pushed into a creative territory that you might never explore alone, and could be just when it's co-creative. So, yes, and we see that it transforms simple conversation into a creativity engine. By accepting and building on each other's idea, partners unlock story possibility neither could imagine alone, and creating spontaneous, surprising narratives that continuously involve in unexpected direction, as we will gonna see. So, one participant in our study described the experience perfectly. She said like this: there was a moment when you start to go with the flow and speak freely, letting the imagination take over a bit. This describes what psychologists call flow state, the sweet spot where challenge and skills meet perfectly, and in improv, you are balancing. High challenge, you have to respond creatively in real time, which is, can be difficult, and you have a low barrier to entry. I mean, you don't need to be an expert to start playing. But here's what fascinated us. As scientists, we faced three fundamental challenges. Can we study this unique and example phenomenon? How do we measure what makes improvisation work? And is it possible to evaluate the quality of spontaneous co-creation? And we needed to find ways to quantify the unquantifiable, the magic of the real-time creative collaboration, which was a big challenge. So we wondered, what if we could take the essence of this collaborative creativity and study it in a controlled digital version? What if we could not even just study it, but also introduce AI as a creative partner? The stage, as we know, has body language, voice, and movement, and the digital world quite different. So we went through several different formats, video, audio, and finally we landed on text. It's simple, scalable, and lets us analyze interaction precisely. And all this gave us our model system that we can control the creative environment and make a data set of yes and games. And this is what we built. We built a digital version of improv games. It's a simple chat interface where two players take turns building a story together. And crucially, that the participants never knew if they were playing with human or with AI. And here you can see the yes and principle in action. I'll give you just a second. Okay, and here our AI in action with a human player. And you can notice the natural yes and flow, and it goes like this. The human start with, hey, wanna search monkeys on the moon? And the AI respond, sure, there is a tribe of moon monkeys with silver tails. And the human answer again, I heard that these monkeys are pretty rare. And the AI respond, definitely, they can only be seen during lunar eclipses. The human had no idea they were playing with an AI. And our AI partner was GPT-4, carefully engineered for improv. And here is a part of the system prompt that you can notice the key elements where we wrote clear yes and guidance and flexibility to handle any story direction and focus on both building on partner's idea while contributing original elements. And we refined this prompt iteratively with a user based on studying their actual experience during the games. And here is the scale of our experiment. It's a 141 human-human games, our baseline for natural human creativity. And also we have 86 human AI games. And we also asked 453 external raters who evaluated all the story without knowing which were human-human and which were human AI. And this gave us a robust data set, but how do you actually measure the quality of improvised story?
So let's talk about measuring the creative play. We have collected yes and stories, both from AI humans and human-human pairs. How do we know if the AI is actually doing well? Evaluating a co-creative improv story is complex. Co-created yes and stories composed usually between 10 and 20 sentences, and there are multifaceted objects that require careful evaluation. For this reason, we developed a few approaches in hopes of capturing the essence of the game. We used human ratings, computational metrics, and Turing test. We asked 453 participants to rate batches of yes-and stories based on 5 criteria we developed with improv experts. We asked 5 simple questions. How creative is the text? How interesting is the text? How surprising is the text? How well does the text tell a story? And to what extent do the participants agree among themselves on the direction of the plot? The results showed that across the 5 criteria, stories co-created with AI were rated just as highly as those made by 2 humans. AI human stories received similar ratings to human stories across almost all criteria. Only they were a bit more interesting for the raters. Using agreement measures, we found that overall agreement between our raters was satisfying, especially for creativity and surprise. Beyond human ratings, we wanted to look for objective patterns in the text itself. We focused on 2 aspects of creativity: novelty and surprise. Novelty measures how much of a semantic jump each turn in the yes-and game makes, meaning are new ideas being introduced. Surprise measures how contextually unexpected a turn is, meaning given the story so far, did the addition surprise us? These metrics help us quantify different aspects of the creative process quickly and in a scalable way. Let's look at each one. First, let's talk about novelty. Basically, what we measure is how different in meaning is one sentence from the one right before it. Novelty, in our case, is calculated by embedding each sentence in the yes-and story using some language model. Then, for each sentence, we calculated the cosine distance between the sentence embedding and the previous sentence embedding. We calculated the novelty for each sentence and averaged over the entire game. This was calculated for each player over all the games, and calculating for each player allows us to separate humans and AI performance. So this plot shows us the scores of 3 groups of interest: humans in human-human games, humans in AI-human games, and lastly, AI in AI-human games. Each bar represents the scores we got when using one of the 4 models we used. The higher the value, the bigger the difference. As you can see in the plot, across several models, humans consistently made bigger jumps. The contributions scored higher novelty. The AI models tended to make shorter jumps and stay closer to the previous turn in the yes-and game. Next, let's talk about surprise. This isn't about how different an idea is, but how unpredictable it is given the story so far. Surprise is calculated without embeddings, instead using language model probabilities directly. For each sentence, we feed all previous sentences as context to a language model. The model outputs the probability of the current sentence given the context. We take the negative logarithm of this probability, meaning higher values mean more unexpected sentences. The plot shows the average surprise of the 3 groups of interest. Humans in human are in blue, humans in AI humans are in orange, and lastly, AI in AI human games are in green. We used 3 different models for this experiment. As you can see in the plot, the AI contributions were consistently more surprising than human ones. Interestingly, humans playing with AI also were more surprising than humans playing with other humans. To assess whether raters can distinguish between human and AI human yes-and stories, we conducted a survey involving 122 raters. We asked the raters to identify if stories were human or AI human. The results were that there was no significant difference between correct and incorrect responses for most stories. And for the few that were significant, they were significantly more incorrect. To understand better the raters' decision-making, we collected testimonials explaining their reasoning, which you can see here. So one of them was, the writing and the context are perfect, definitely written with AI. This was written about a human story, and AI wouldn't write the following sentence ever. Yes, and I never saw something like that in my life. And this was said about an AI line in an AI human story. So let's talk about what it means and what's next. So we showed our AI can play along in the yes and game. But the real question is, how can AI become a creative catalyst and not just a creative companion? In the future, we want to move from looking if they can match humans, then if they can enhance human creativity. The next projects will be working with improv experts to see how they can improve with AI, building systems to adapt to individual creative styles and learn to challenge players in a personal way, to expand beyond text and include movement, gestures, and other multimodal creativities, and to develop AI that doesn't just follow the yes and rule, but helps humans discover creative directions they might not have found on their own. This work opens a path toward understanding how AI can genuinely augment human creativity processes, not just participate in them. We're not just building better AI partners, we're exploring new ways humans and machines can create together. Thank you for playing along, and please let us know if you have any questions.
Perfect. Thank you so much. So we will try to see if we can have a questions answered. Let's see. You can hear me, yes, guys? More or less.
We don't really hear you that well.
So how can we solve this? Better?
Maybe if I'll turn to the YouTube, it'll be better. Let me try.
You try to mix it up.
Well, let's try.
Oh, hi. Can you hear me?
Okay, it doesn't really work because it's very delayed. Maybe if you can speak clearly to the microphone, we can try and hear you.
Okay, I'll try slowly. So thanks for your talk. I really liked the work. So my question is, have you considered synthesizing, because you started in the motivation talking about theater improvisation, and I wonder how this model that we build could be extended to an actual speech-based interaction. Like, I can imagine you synthesizing the generated text and actually improvising in an actual performance, and I guess that would generate maybe different results because you also have now the speech dimension, and I think that would change how the human perceive the generated response. So just some thoughts about that, if you have considered using in the future speech, actual speech as part of the system.
That's a great question. So the yes and game is an enclosed small world that we felt comfortable trying to work with. And definitely like bigger parts of speech and other kinds of co-creative work are definitely something we're very interested in. We think that because we started off small, we might be able to expand this from this where we have some control to maybe other kinds of speech and other kinds of interaction. And hopefully we're interested in co-creative endeavors in general, not just smaller yes and games.
Another question? No? Well, because it's not that simple, I think we can stop here. Thank you very much, guys. We appreciate
Thank you
your
so
participation.
much for letting us join remotely.
Okay. think it's okay, no? Okay, we are ready for the last talk in this session. May is going to talk to us about turning linear stories into thrillers, the impact of story recording and familiarity.
Hello, everyone. My name is Macy. I'm from Rensselaer Polytechnic Institute. We're in upstate New York, not in New York City, but in Albany area. So this work is something that I actually always want to work on, basically switching between style of stories, from a linear story, from a normal story, to a thriller story. That's something I always want to work on. I tried for many years, and then, long story short, was hard until GPT-4o was released. Then my problem sort of solved. I still want to talk about the motivation, the setup, what I wanted to do, what I eventually did, and the evaluation of this work. So narrative suspense, I think, is one of the very interesting topic. It's something that, of course, like linear story can be very interesting too, but the suspenseful story has its own charm. It's something that really engages us, immerses us into the story. We're actively acting as the characters in the story, try to figure out what is happening, what shall we do, what can we do, or what does character think, or why they were doing so. So it's really something that makes the audience very emotionally and cognitively immersed into it. And then in this process, how to create suspense in the story, there are basically, I mean, I shouldn't say basically, but there are two aspects of things. One is how do you present the events in the story? So in a suspense story, if you didn't pay a whole lot of attention, actually the ordering of events are different from if I just tell a linear story from beginning to the end. Most of the suspense story, to reach the suspense, they actually tell you, they show you the most dramatic moment at the beginning, and then they just hold you suspense level there. Then they gradually release what is going on. They eventually, of course, tell you the story, but they gradually release what is going on, and in the middle, they add all of those emotional cues to accumulate your sense of suspense. So it's a cognitive and emotional experience. So to put this into more formal word, this work is largely inspired by Ed Tan's work, the narrative structure of movies, and by Lin's experimental work on reordering events in a story to create suspense. So to put this thing, what I said more formally speaking, so a typical linear story start with the beginning of the story and end with the end of the story. The beginning of the story, we typically call that the initiation event. And then the end of the story, we typically call that outcome event. In a suspense sort of like reordered version, we typically start with the outcome teaser, with the outcome of the story first. And then we get some initiation events, we add delays to hold people's tension, and then eventually, of course, we resolve that tension. So in this work, also, sorry, I should talk about once you want to reorder the events in the story, you actually inevitably, you find out your story have to be longer because you need to hold people's tension in between. And then there are techniques for both holding people's tension and to enhance that experience of suspenseful experience. So there are basically you try to add delays. There are digestic delays and non-digestic delays. Digestic ones are, this is the story of the turtle and the rabbit racing, right? Digestic delays are those that are related to the story. So something that happened in the story that you now have to listen to me talking about it before you know the result. The non-digestic delay are things just I add in some description of the environment, environmental factors I can talk about. I, as an observer, what I'm thinking about, what may be happening, but both of them has the effect of delaying, telling people the outcome of the story. There are also like phrases, sentences that describe the emotional experience of the character in the story that acts to enhance the audience experience of suspense, because the audience are typically, they're gonna automatically experience what the character experience. Also, you can get perspective shifting. I can tell the story from a third person perspective. I can gradually just hold that information and gradually step by step releasing this to the audience. So I've tried to, to recap, I've tried to do this work actually for quite a number of years, used many techniques before GPT-4.0 was released, and was never satisfactory to me. Rewriting story to a higher standard was never easy. Then all of a sudden, the problem becomes prompt engineering, and I just practiced several times. And then, so the exact procedure is, now I want to do this work that I give a standard prompt that can transform a story from linear story to a suspenseful story. It's rule-based because I give the exact rules in the prompt, and then I give those suspense-enhanced techniques that I outlined here in the instruction. And then the specific instruction, the eventual version is this, but that basically just captures everything that I said in the previous slide. So I did so here's an example of the rabbit and the turtle story. So the original story, we all know it. It's just the rabbit, the hare starts, it runs faster, it mocks the turtle to begin with, and then it naps in the middle, and then by the end, he loses the game. But if you reverse the order, it would be like present the turtle finish first, and then we talked about what happens step by step, the rabbit's overconfidence and turtle's patience, and then eventually we tell the end story. So here's actually the reordered story that's slightly longer. I will, since I have 1 minute left, leave this on the screen for people to read it. So it's the partial outcome first. He says, okay, so this is the result. But to everyone's astonishment, they also used this emotional language. It wasn't the speedy hare in front, but the slow, steady tortoise. And then for the digestic delay, we talked about what happened in between, and then the resolution. Now we reintroduce the result, but with the confliction resolved. So to testing whether this sort of like procedure actually works, I set up an experimental study with 2 groups. One was the linear story, just a normal story, and the other was a suspense-enhanced flow. That basically means I reflow the story. I also instruct GPT to add those techniques for enhancing the subject's experience of suspense. So I recruited 17 subjects, and then each of them read 4 stories. I also want to add another factor that is familiarity. So like some of the stories people know very well, some other stories people are unfamiliar with. So I added that as another independent variable. So each of the participants actually read 4 stories. So the linear versus nonlinear, and then familiar stories versus unfamiliar stories. And the dependent variable are just a bunch of Likert scales. The study was done on MTurk, the people's perceived level of suspense, their engagement level, their perceived engagement level, their perceived narrative coherence of the story, and their perceived level of familiarity with the scenery. I'll bypass the statistical details, but basically the result shows the flow worked. The reorder story are typically, or actually significantly, having higher rating on suspense and emotional engagement for the subjects as well. Familiarity matters, but worked in the opposite way. Initially, I thought maybe novel story, people will feel more suspense in the novel story, but in this study, people actually experienced more suspense in the familiar story. Clarity wasn't a strong predictor for anything, like people's perceived clarity of the story are basically constant. That could be just because they're all GPT generated. And engagement, people's perceived level of engagement strongly influence the perception of suspense. So as for future work, I think there are other like nonlinear structures that I want to explore in creating this experience and interaction. This is static story, so interaction between player agency and suspense, and also try this in maybe a cross-cultural multimedia format. That's the end of my presentation.
Hello. Thank you very much. Very good. You're working on a very elementary definition of suspense, right? Do you think that something similar could be done for the more complex one, for thrillers or so, where you have the character and the suspense is all about the possible outcomes and nobody imagining a positive possible outcome? And so you see all these possible ways in which things could end badly, and the audience is suffering, and then at some point the author introduces one way for the character to survive, a James Bond movie thing or something like that. You think something like that could be done?
I think the mechanics for creating suspense is the same. Of course, this technique itself wouldn't be able to create the super rich characters. I think that needs either additional modeling, like how we build characters with or without AI, or if we want to use GPT, then a lot more instructions to that. But the theory itself was not drawn on these very simple stories. They were actually drawn on movies. Right. So it's actually 4 more complex stories.
Nobody has a question? No, could you just elaborate a little bit more about the evaluation you did? Because
yeah. So it's between subjects. It's a mixed design. So the 17 participants, each of them either read a linear story or the reorder story, so that they don't read both. But on the 4 different topics, each subject read 4 stories, each on 1 topic. So it's a mixed between group design. With 17 subjects per condition, 34 subjects altogether. And then the measurements, like I said, are they each read 4 stories, and then the measurements are Likert scale on their perceived suspense, their perceived engagement, clarity of the story, and how familiar they feel about the story. So there's a design of what I think those topics are familiar topics, but what the subjects actually think. So if you're actually curious, it's not on my computer, I was like, I can show you the rest of the stories. One is about a person coming home late night, there's a car approaching, so then it turns out to be someone visiting his neighbor. The other is an elevator, a person heard some noise, and then of course it turns out to be nothing too serious, but so those are the other 2 stories. And then, so the idea is, let me see whether reordering all of the stories have an effect, and also how the topic itself affects people's experience, or affect how this manipulation can be effective.
Okay.
And I noticed that your example for the tortoise and the hare, it works really well, but in part, it's because of the changes in focalization, right? Because the bits you're shifting about are the bits where you're focalizing on the tortoise and the bits where you're focalizing on the hare. Do you consider that somehow in your model? Is that part of the information that you're handling, that you're representing? It may not work if you just reorder things and they're all about the tortoise.
I think the basic idea is still to reordering things. That this perspective shifting is indeed the technique that people use for creating suspense in novels and movies, but it happened here by accident, or it just happened here. It was not by design.
Okay.
Did you look at ways when not just reordering the story could make a suspense, but in some movies, for instance, they put a different music that creates a sense of suspense, or maybe they just show something on story that not necessarily is reordering something in how you tell it, but there is some element that creates that suspense. Have you looked at that?
Yeah, so on top of reordering events, there are other techniques for emotional sensory amplifications, like playing music or sometimes giving even like verbal cues. They all count. But I think essential to this theory, or essential to this work, is reordering have to happen. If reordering doesn't happen, a linear story, of course, like writing is rich, but the linear story, most of the time, you wouldn't be able to experience that suspense. Just by all of these techniques, you may feel like someone's trying to create suspense, but that reordering is really the key. You do combine, but the answer is you do combine reordering with this technique, because once reordering happens, that basically raises your arousal at the beginning, raise your suspense level at the beginning, and then you have to hold it. To hold that suspense level, we need all of those techniques. I believe 80% of the chance. Like language is so rich, what can I say? But I think most of the cases, the reordering is important. Or also that's where the theory that I based this work on, basically Ed10 and Balint. So I based my work on their prior theoretical and experimental work. That's also the theory says.
Well, thank you very much for your presentation. This ends our sessions, and now we have the coffee break.
Just a quick announcement for just remember that after the paper presentations will be our cultural activity with the Victor Leaders Group at the Lake House. Is to the right from the ESC here at CDC. So we'll see you there. Hope everyone liked the presentation too. And let's go to the coffee break.